get your hands on strings. Yeah. So that's it for today. If you have any questions, you can come up. So otherwise, we can wind up.
No questions.
Okay. Okay. We'll wind up.
Thank you.
Okay. Thank you.
This meeting is being recorded.
Okay. So today, it will be going to be will practice. In fact, it will be interactive session. So I will go through these practice problems, and you have to paste that code in the chat by writing it in the chat window, and I'll validate it. So if there are any corrections, we can do it. So we'll do some of them, and then later on, you you can continue and uh, complete these tasks. And we'll see, combining all these topics, how to build a mini calculator. So combining all these topics that we have learned from day 1 to day 6, we'll build a mini calculator so that will combine all our topics, and in fact we'll see how to write conditional statements, loops, functions, all those together at one place. Okay, so let's start. So I'll you can paste uh, this code in the chat. Okay, so take a user input and greet the user. So the output should be in this format. Just write it in the chat. How would you print it?
Okay, sir. 1 minute.
Okay. Okay. So I see that you have sent this code. Okay, let me start sharing. Let's review this. Okay. So This is correct. So one thing you need to make sure is use formatted string F double quotes around it. So whenever you are using print text along with the variable that you are printing, then you should use, and you should take input from the user also. So that would be name equal to input of enter the username. Enter the name. Okay, so along with the text, we want to print the variable name, then we'll use formatted string. So F double quotes inside it, you have to print. Okay, so let's start with the next. Okay, so you can start working on this next. Check if number is even or odd. So I will give you a hint. So here hint is we need to find out what is the logic. So what is the logic to find a number is even or odd? If it is divisible by 2, then that is even, else it is odd. So we have seen in expressions various uh, right multiplication, division, modulus. So you can take those and find whether number is odd or even. Okay, so you can print that code in the chat once you are ready. Okay, so yeah, this is perfect. So we are taking this logic. So here you notice the logic building is very important. So this part we are using conditional statement to build our logic. So conditional statements we are using, and this is a formatting. Good. Okay, so just double quotes around it. In enter. Okay, so you have given int and int, so it should be input. Input should be inside int of input. Okay, so 10 is even, 11 is odd. Okay, so now you can write one more program. Find the largest of two numbers, or you can pick this also. Use for loop. So anyone is fine. Use for loop to print numbers 1 to 10.
In third program, which keyword should we use?
Okay, so here the hint is you can use max function. So max of a comma b. So A is one variable, B is one variable. So A will have one value, B will have one value. So max function, using max function, it will check which number is maximum of 2. Or one more thing you can do, you can write if conditions. So two hints, like this is one way. Another way is you can write if condition to find out which number is largest from a given of two numbers. From a given two numbers, which number is the largest one? Okay, so yeah, this. Let me check this. So we are taking one input and another input and finding the largest of two. Okay, so to define this variable, you need to use, if you want to define this type of variable, you need to use dot format function. Dot format of largest. So that way it will take this format. So the largest number is, or you can just directly take this. So you can look at it like if you want to define just empty curly braces, how to access a variable's value with just curly braces, you have to use dot format function. So you can revisit this later and find out. So this is not working here, but I have changed this to F string. Okay, so let me enter 10, 20. So 20 is the largest. Okay. So you can quickly write a program to print numbers from 1 to 10 using a for loop. Okay, let's see. So, okay, so you have written in this way. So where is for? You have to start with for loop. So here it should be for. It should start with for loop. For I in range 1, 11, print I. This is correct. So what is the other way to do it? So this is you're doing it manually. So this is perfect. It's bringing 1 to 10. But what's the way to dynamically do this same thing? So you can use for I in range. You can declare n here. N is equal to 10. For I in range 1 comma 1 comma n, and print I. So you can see it prints from 1 to 9. Actually, it's prints from 1 to 9. So what I need from 1 to 10. So I can do n plus 1. Same thing. You have done 11. So I'm doing n plus 1. So it's a way to dynamically define. So tomorrow, like my number might change. So it might be 20 something else. So that way I can handle those kind of scenarios. Yeah, perfect. That is fine. So next, calculate the sum of first n natural numbers. So let me explain you, give you a hint. So here the hint is, so we have n equal to 10. So that means each and every number should be added. So that means your final result would be 1 plus 2 plus 3 plus 4 plus 5 plus so on up to 10. So how would you write a program? So that would add all natural numbers. You can write it.
Sir, here we should use which keyword?
Okay, so here you can use um, range, for loop and range. For loop, inside the for loop, you can do a summation. So inside the for loop, you can do sum. This is one thing. Or uh, another way is declare an output variable. Declare an output variable. So that will hold our final result. Okay. So that would hold my final result. So I can say result equal to 0. Then I will write for I in range. So inside this, I will write my logic. So here will be my logic. So I will sum it up, and the final result I will store it. Since I have declared result equal to 0, the final result I will store in result variable. Then print result variable. You can try this. You have to write the logic here. And what would be the range? You can declare the number what we are using here. Okay, so let me try this. What you have written. Sum equal to 0 for I in range 1 comma. Okay, so n value also you have declared it here, right? So let me take n equal to 10 here. Yeah, this is correct. So what we are doing here, so this kind of programs, what we have to do is you notice we are declaring an output result, output variable. We are declaring output variable separately and setting it by default 0. Then what we will do is in for loop, we'll loop it one by one and calculate this logic, then store it again here. So this statement is finally equivalent to sum equal to sum plus 1. So this is our logic. So that calculates our natural numbers. So this is our logic and this is our print. So what I mentioned here, right? So first you have to declare output variable, then loop through that n numbers. What our n number is 10. Then calculate the logic, then store in the results, and finally print it. So that is how we are doing it here. So similarly, you can complete this factorial and reversing a string. Okay, so let's do. So we have seen this. Let's do for string. So how do you reverse a string? So let me know what program, how you write it. So
Sir,
let's consider any string. Yeah. Okay. You're saying something?
I need to practice strings, sir. I'm not that
Oh,
good.
okay. Okay, no problem. So we'll see. So let's say a string is A, B, C, D, E. So first we have seen slicing and dicing, right? Slicing and dicing. So the same concept we can use. It's start, stop, end. So similarly, like since we want to reverse, we want to reverse the string. We want to access the string from in the reverse order. So I'll say -1. So -1 means I'm accessing the string in reverse order. So see, I'm accessing E. So then what I will say, go back. So it's not bringing in reverse order. It's going in reverse order, but it's not bringing me the text or string in reverse order. So for that, what I have to say, start and end. So I need to say start and end is nothing. So that way it will bring my thing in reverse order. So this is a simple way. So you can do the same thing using for loop also. Like loop through each of the string and print in reverse order. So that way also you can do it. The same way, how do you count vowels in a string? We have seen string methods. So notice on the question, input a string. So given a string. So there is a string. Our string is A, B, C, D, E, something. And we have to declare vowels. So since it's asking us to count how many vowels, so similar to this problem, where we have declared our result equal to 0, right? So in the string problems, what we will do, since it has asked us to check how many vowels are there in a string, so we will define that vowel since we know what are vowels. So I will define A, E, I, O, U. So that is how it will work. So now I need to compare this with this. So you can write for loop for I in for V. I'll say this V. I'll say this S for V in S. And one more thing you notice, it's asking us to count the number of strings. So again, what we will do, we'll declare the output variable count equal to 0. So this is how we'll do problem solving in Python. So we have to carefully read the question and decide what all the variables that I declare that hold my output variable. Is there any variable that I declare to complete my problem? So since this part I know that I need to check in vowel, so I will define the vowel here. So here I'll say uh, count equal to count plus 1. Then finally print. What should I print? What I need to do? Count. So I'll print count outside the for loop. So you can see this is not in the for loop. Now it's counting 6. So are my vowel 6? 1, 2, 3. So it's not 6, only 3. So I need to define my logic here to handle that. Okay. So you can write this program. You can complete this to count a number of vowels in a given string. So you can take input as uh, any string that user can provide. Same thing, check if string is palindrome or not. So this is these are very important programs. So this will build our logic. How do we work with strings, as well as a lot of interview questions. These type of questions are asked to test us. So if we are hands-on, if we keep practicing this, so we'll be able to remember this quickly and complete this in time. The same thing, print multiplication table of a number. So this is also very interesting program. So we can complete this. Next, we'll see a mini project. Okay, build a text-based calculator. Okay, so what are the project requirements? Ask the user two numbers. So we'll ask user two numbers. So that means we have to define a equal to input of enter first value, then b equal to input of enter second value. Okay, so based on the question we are going by. Okay, ask the user for two numbers. Since it ask, that means we need to prompt the user to input. So that is okay. So what we'll say will int. So since we are entering numbers in the calculator, we'll wrap it around to an integer because we don't want anyone to enter letters in our calculator. Okay. So let me, if I enter A, it will error out. So that's why we are using int so that our calculator does not break. Okay. So next we are saying ask which operation to perform. So we are not doing it directly. So we will ask user, what do you want to perform in calculator? Do you want to perform addition, subtraction, multiplication, division? So same way, I'll say, okay. So add equal to in input of enter um, okay, so what we'll do, we'll define just one operation. What kind of operation you want to perform? So input of enter with operation. So we'll give options: plus, minus, multiplication, and division. So we'll give these options to the user. Okay, so let me run this. I'll run this once again. So 10, 20, and we are asking what kind of operation you want to perform. Plus, minus, something. So I'll say plus. So now whatever he input, we want to take that. Okay, so we'll write conditions. If operation, so the user has input the plus symbol. So we'll say if operation equal to plus, then what we have to do? We'll say print sum of okay, print a plus b. Print we'll say print a plus b. So let's do simple. We'll do a formatting later on. Okay, so 10, 10, 20, and plus. So it will add it. So based on the user's operation. So similarly, so whatever we are doing is a logic building here. Okay. So the above part is we decided what inputs to take from the users. And now this is logic building. So same thing, what I will do, I'll copy it here. If user entered minus, then I want to do minus. If user entered multiplication, I want to do multiplication. If user entered division, I want to do division. So notice if you are changing here, we need to change in the print also. Division. Okay, so we do 20, 10. So now it's asking what operation you want to perform. So I'll say divide. So it will divide the value. Now let's say we want to continuously run this program for at least 3 times. So what we can do? We can write this entire thing in. We can let's say I'll define n is equal to 3 while I less than 3. So we have 4 operations. So we'll give 4 chances for the user to write. I is equal to 3. I less than or equal to 4. Execute all these. Indentation. Okay. So whenever we are writing while loop, it will take 4 spaces. So all our code should come here. This is how we have to modify it. Mm. Okay, so let me run it. Does not match outer level indent. Okay, so this kind of problems you will face in Python because indentation is very important. So see, my last if condition is not properly indented. So I need to properly give spaces that makes it in the proper block. So this means I'm writing everything in my while loop. While loop, 4 spaces. Everything should come 4 spaces. So 1, 2, 3. So one more space should come here. 2, 3, 4. 2, 3, 4. Okay, let me try run this. Okay, so this ran. So let me quickly check. Okay, so this is how it will look like. So, okay, so let me run this from here. Okay, so I'm using a while loop. So this is a continuous loop. So until you give Q, that means we want to exit. Until you do not say you want to exit, it will keep on running. Okay, so first number 10, second number 20, and operation is plus, and again it started. You can see using a while loop. So while loop is causes infinite loop. So that means we are saying every time it's true. So similarly, we can define how many times it should run by default, like I equal to I less than some number. So while loop will go into infinite loop. So if you see the icon here, it says it's still running. Okay, so it's still running. So until you quit it, it will keep on running. So if you enter any invalid number, then it will break the program. Could not convert a string to float. And here you can see a number cannot be divided by 0, right? So anything divided by 0 is infinity. So those kind of scenarios also we can handle. So if whatever the number user has entered, if it is not equal to sorry, it's not equal to 0. Okay, even if it is not equal to 0, then only divide the number. So this is a check. We are doing a check so that the program should not error out. Checking divide by 0. Okay, so everything whatever we have did, so we are putting in while loop so that we keep on looping this calculator of small calculator program so that we give the user option again and again to execute it. And here you can see if, else, elif, and inside the division we wrote again, so with a indented block 1 2 3 4. So that means this block of code comes under this elif. So this is multiple level of conditional statement, nested conditional statements. We are using it to build this robust program, calculator program. Then if you enter Q, it will exit. So we talked about break statements, right, in the looping. So if you enter Q, okay, no, at the operation, if you enter Q, it will break it. So let me run it. So if you say 10 as a number, 20 as another number, then we have an option here. You can see choose an operation, plus, minus, multiplication or division, or enter Q to quit. So enter Q to quit. Then it exited out of while loop. So here you can see book kind of icon. So that means our program is not running. So if you see this, now our program is running here. So it's in the loop. So this we can build it. We can write it in our program. Elif. So I showed you first in a simple way so that we can, whenever we have some problem statement, so this is how we need to address. First, what is being asked? So the request is ask the user. So that means, okay, so based on the question, we read that, okay, so we need input from the user. So that means we'll use input function because that is the way we can get value while running. And ask, so you can notice the question, ask which operation. So again, by reading the question, we are able to understand that we need to use input function because we need to take operation values while user executes the program. We need to take his inputs and perform operation. Then based on what he gives, we can write conditional statements. If this operation, whatever in value he input, equal to plus, minus, star, or division. Elif. And here, same case. We can check write one more condition, logic, to check if our calculator is divide by 0, if our numbers are divide by 0 or not. So only if the number is not divisible by 0, then we'll divide. Otherwise, we'll get an error. So to prevent errors in the program, we'll do these kind of checks. Okay, so this is how this mini project. So this will cover everything what we have learned so far. It will cover loops, while loop, as well as it will cover conditional statements, so nested conditional statements, and how to build a logic. So majorly in programming is the logic building using those statements. So whatever the concept we have, conditional statements, for loops, while loop, all these things are there to finally build some logic. So that is the main crux of our final program. Yeah. Okay. So if you have any questions, let me know. Otherwise, we'll wind up today's session.
Question, sir.
Okay. Okay then. So we'll end it here. Meet tomorrow. So today we'll see list data structures in Python. So like strings and integers and all other data structures. So we have one of the data structures. It's called list. So lists are one of the data structures that are used heavily in Python. So we'll see what are lists. Okay. So lists are ordered collection of items that can store multiple values in a single variable. Okay. So here you can see this is single variables. You can store multiple values, strings as well as numbers. Okay. And a list is a ordered, so this is very important. So list is always ordered and it's a mutable. So you remember in the first day we discussed about two types of data types. One is mutable and immutable. So this list is mutable collection of items. So we'll see, uh, we'll recap that what does mutable mean. Is where each item can be of any data type. So inside a list, it can be integer, it can be float, it can be combination of strings and float, so on. A list allows you to group related data together under single variable. So under single variable, I can declare a single variable A, and inside that I can put combination of strings, integers, all those things. Okay. Think of list like a row of boxes where each box holds a value. It can be number, it can be string, it can be floating point values, etc. Okay. So lists are enclosed in square brackets. So they are enclosed in square bracket. Here you can see these are square brackets. So this is how list is defined. So if you declare a variable equal to and give square brackets, that means this is a list. So that's how we define a list. Okay, so what are the key properties of list? So it's ordered. So always the items inside a list, they are ordered. They have a fixed order. The first element stays first, second, third, and so on. Then it's a mutable. So if you change no value from a list, so it does not create a new memory. So it stores in the same memory. It replaces this value in the same memory. So it's a mutable data type. It can change the list after it's created. Okay, so it allows duplicates. So there is one data type that are sets that does not allow duplicates, but lists allows duplicates. So here you can see cherry. So if you give it 2 times, it will allow it. But when it comes to other data type, let's see. Let me take this a sample. Okay, so might be this is not the right example. Okay, so it will allow list will allow duplicates, and it's a heterogeneous. That means you can combine numbers and strings, floating point value, and boolean. So all the data types in one list. And in previous class in strings, we talked about indexes, and uh, here also in lists, each of the value is indexed. Okay, so apple, banana, cherry, so these values are indexed. So index starts from 0. Okay, so this is how you can access a list of square bracket open and close.
and you can give the index position to access the list. Okay, so now you can create dynamic lists also. So it can grow or shrink in size. So you can add or remove elements anytime from a list. So let's see some of the examples here. So we are saying shopping cart equal to milk, bread, butter. So these three items we have, and we are printing it. Okay. So this is our list. So this is a simple list. This is a simple list. So similarly, you can create lists, uh, list of your three favorite movies, list of your five best friends, create a list of numbers from 1 to 5. So this is how list can be created. So give an open and close bracket and assign a variable. That's it. It's so simple. Now we'll dig deeper into this, how to index, how to do slicing and dicing in the list. Okay, so whenever we have an list, we'll have an indexing on that list. So let's see what are the indexes. So I have a numbers variable declared, and that has a list 10, 20, 30, 40 and 50. These are the items in my list. So let me run this numbers dot index. So I'm checking what is the index of item 10. Okay, so it says 0. So 10 stands at 0 index. Similarly, I can type 20. So 20 is at number 1 and 30 is at number 2. So similarly, this index, it always starts at 0, then next value will be 1, 2, 3 and 4. So indexes always will be n minus 1. So how many items we have in a list, count of those items minus 1. Those will be our indexes. So how many items we have? 1, 2, 3, 4, 5. So 5 items. So 5 minus 1. Oh, sorry. This will be 4, not 5 actually. So 0, 1, 2, 3, 4. So this is our list. What is an index? That's now we have seen this is an index. Okay. So let me print this index. So these are positive indexes. So likewise, when we are accessing a list from reverse, from the back of the list, from the end of the list, then we'll say negative indexes. Okay, so these are my negative indexes. So positive indexes always starts from 0 whenever we are accessing a list from the beginning of a list. But whereas if you are accessing a list from the end of the list, it will always start with -1 and go up to whatever the number. So let's say these are my lists. So I'm accessing my list from the end of the list. So this will be -1. So 60 will be -1. Then I will move back. 50 will be -2. So similarly, I will count -3, -4, -5, -6. So this you have to understand clearly, and you have to know beforehand, practice this, so that if you are solving any problems related to lists, this will be very much handy. Okay, so now
in that print statement, we have minus len numbers minus I, right?
okay, so these are formatting. I have used it to showcase you what are the indexes. So length is a function that will count how many items I have in a list. So
Yes.
we can get it here. I'm just formatting this in such a way that the output here showcases like what is the index as 60, 50, so that you have a clear idea how our indexes are assigned. So that's it. So I'm using a formatting here.
Like we have given two negatives here, right? In
Where?
print statement. In print statement, we have given minus
Yeah, yeah.
length of bus and minus I. So how it
Yes.
is executed?
Okay. So first, what it's doing is it's counting the length. So
Yeah.
how much is the length? It will be 1, 2, 3, 4, 5, 6. 6 is the length.
Yeah.
And 6. And whenever we saw this in for loops, whenever we start a range function in for loop, it starts with 0. So our first loop will be 6 minus I, that means 6 minus 0. Okay, so our value will be 6. Then outside we have one more minus. So what we are saying, instead of 6, let call it as minus 6. So we are just formatting here with a minus at the end. So this will be printed. Similarly, now next I will become 1. Now our how much is the what is the length of numbers? That is 6. 6 minus 1 equal to 5. So my result will be 5. But what I am saying, outside put a minus 1 here, so that it takes minus 1. So that's a formatting in a way I wanted to show you by executing it. So what are the indexes assigned to each of these items when we go in reverse direction? Okay. So, okay, let's move to the next topic, accessing a list. So now we have seen how to declare a list and what are the indexes of a list, how indexes are assigned when we are accessing lists from beginning to the end and in reverse order. Now, let's say I want to access number 10. I want to get that number 10. How do I access that? So whatever the variable that I have, so I have this variable numbers. So I'll say numbers, then I'll say open and close bracket. Now I will use that indexes. So just now we learned about indexes, right? So based on our knowledge, this is at 0th position. So if I want to access 10, I have to put a 0 here. So that means this is a way of saying that I want to access number 10 from a list. So if we do that, it will print the value 10. So similarly, I want to access number 4, fourth position. So this is 0, 1, 2, 3, 4. So at fourth position, it should be printed 50. So this is a way to access a list. So similarly, if I want to access list from in reverse direction, so from 60, 50 in a reverse direction, if I want to access a list, I can use negative indexes. So if I say print numbers of, so this is my variable. If I do a open and close bracket, so it's a way of saying that I'm accessing a list. So if I say -1, so I'm accessing list from reverse direction. Similarly, I can say -2. If I say -2, so 50. Same thing in strings. We have seen strings uh, uh, session also. In that also the same things plays out. So even if you're accessing from positive side of the list from beginning, this is how you can access. If you're accessing from the uh, end of the list, so this is how you need to access the list using indexes. Now let's see if I want to slice that list. So I want to use particular
Questions
slide.
for
Yep.
Yeah.
Any questions?
in indexing, if we have two same values, right? Like we have seen in cherries, you have typed, right? We
Yeah.
have two apples. So which index it will take in the list? So if you
Okay.
want
So
to do this,
it will take next index. So 0, 1, 2, 3. So 0, 1, 2, 3. This will be 3. So index will not change. So even if it is a duplicate, it will take another
For
index.
duplicate value, it will consider it as one index only.
Yeah, separate index. If you see here, let me run this statement. So even if it is a duplicate, it will consider a separate value and separate index. So if you try to access this, so I'll change the variable name also. Fruits dot index. Okay, so this
It
is
will,
cherry. So it's
it is
taking
first.
index 2.
It is taking the first duplicate index, right? No. Okay. Okay. So like
Okay,
both
so the values are
both
same.
duplicate.
Since the values are same, it's taking the same one. Yeah, but it will allow duplicate. So it will allow. So let me run this statement here. Let's see. Okay, so this is different index. So it will. This is apple, banana, cherry is 2. Again cherry. This will be considered as another index.
Yeah.
But since the name is same, by default it's accessing the second place. Since the names are
Okay.
same for both of them.
Okay. So like if we are having two duplicate value, it will consider the first one.
Yeah. So if you are no, since you are accessing, I'm checking the index through this index function. So this index function is considering the first, second value. But in reality, we have cherry as this is at second place. If you loop through these values, this will be considered second place. This will be considered third place. So this will be considered another value, another index. But since this name is same, right? So by default, it's going back to this. So this function. So if I'm trying to access through this function, it's by default going to this value. But if I run through a for loop, here you can see I'm running through a list, and 2 is this value and 3 is this. So this will be considered separately if we have duplicates also, separate index.
Okay.
Okay, so let me go back to slicing. Okay, so if I want to access a particular slice of a list, so here this is how I can define. So whatever the variables, numbers, then open and close bracket. So I need to define what is the start and what is the end. So my start will be start equal to whatever the index number we are starting at, and my end will be, so whatever number I define at end. So if I say 5, it will always stop at n minus 1. So let's see that as an example. So I'm saying numbers of 1, 4. So it will start at 1. So let's do this. This is 0. This is 1. So what we are saying, started here 2, 3, 4. So you can notice here I said 4 here, but we stopped at 3. So in lists or even in strings, the end number will be always n minus 1. So if you define this, whatever you define the number, and it will always take n minus 1. So it will stop at whatever the number you define minus 1.
If
Okay.
you want to consider the last value 60,
Okay.
so we will type.
So
So
if you
one,
want to consider last value, you can
yeah,
say 4. 4, and let's say I want to access my 60 value, and whatever after it, I can say 4 and star. So it will access. What happened? Okay, so I'm trying to access 2 number. Okay, let me just say 0, 1, 2, 3, 4. Okay, 4 is this. This is 5, not 4. Okay, so if I want to access 60, I need to say 5. Okay, so it has access 60. So you can just call it 5. It will access single number. But if I want to say access everything after starting at 5, then now we don't have any number. Let's say tomorrow someone added more items in a list, and with your this lines of code 5 colon, it will access more list starting at 60, then whatever comes after it. So it's like we didn't define any ending. Whatever maybe after this number 60, take all of them. So that's what it means.
okay.
So similarly, here we can see we are accessing a list from the beginning, and here we are accessing a list from the end. So first, let me access a list from the beginning. So if I want to access math, so first subject is math. If I want to access last second from the reverse order, English, what is after the English in the reverse order? History. So last 2 subjects. So if I want to access last 2 subjects, this is how I can access. Now in list, same thing plays out as with strings also. So in strings also, if I want to access in reverse order, this will get changed. So here what we said, start and end. So here end come first and start. So here we are not declaring start here, we are declaring end here. So we are saying end at -2. So in reverse order, positive, let me declare positive here. So positive numbers, what would be the positive indexes here? Positive indexes would be 0, 1, 2, 3. So these are my positive indexes. Okay, so negative indexes, what it would be? So it will start from -1, -2, -3, -4. So this will be -4 if I start accessing in reverse order. This is -3, -2, and -1. So this is how it will work in indexes. So what I'm saying, I have defined my end. What is my end? -2. So I'm saying end at -2. So whatever could be the starting. So then it says first subject is math, last 2 subjects are history and English. This is how it will access. So
So
these,
for minus,
yeah, go ahead.
for -2 also will take the forward number, right? The forward values, history and
Minus,
English. And positive also, it was taking the values from right side. Like we have
um,
typed in previous one 50, right? Then it was taking 50, 60, 70, 60,
hmm,
70, 80. And in -2 also it is taking history and English. So what is the difference? Like in both positive and negative, it is taking the values from the
no,
right
no.
side.
What I'm saying is, in the negative values, this is. Let me define both at once in positive order. So in positive order, we'll define start first and next. If I want to access a list from beginning to end, so I'll first define what is my start, then end what is the end. So end, always end equal to whatever number is n minus 1. And here, when I am accessing list in reverse order, I will define my end first. So end will be whatever number we have defined. So it will not take n minus 1 here. So in reverse order, one more point you can note, it will not consider n minus 1. So it will consider whatever the value it is, whatever the index value in negative integer. So what I'm saying, so before exit, okay, so let me comment this out and show you one more time. So if I access -1, what will be printed? If I access -1, so what will be printed?
English.
English, right? So same way, if I access -2, history will be printed. So what I'm saying, this is my ending. I'm not defining my start. So this is my end. End at -2. Start at whatever the starting point is. So English is the starting point. End at -2, I'm saying. So this is how both values are bought here. I hope this is clear.
Yes.
It's clear, right?
Yeah.
Okay. So similarly, there are some tasks you can practice it. Access a first item from a list of numbers. Slice, do a slicing of list. Indexing and slicing you can practice. So these are very important. So indexing and slicing, it comes all the way in for loops, while loops, strings, lists, and what we have tuples. So all of those we have indexing and slicing. So next, let's say I want to modify my list. So my list is colors red, green, blue, and I want to replace red with yellow. So I can say first I will access this list. So I'll say colors, colors of 0. So I'll access this first. So this is how I'm accessing. So what it will bring? It will bring a red. So let me comment it out. So if I access this, it will bring red. So next what I'm saying, replace red with yellow. So this line says replace red with yellow. So I'm replacing. So if I print my list now, the red will not be printed. The yellow, green, blue will be printed. So this is how we can modify a list.
For replacing, do we? I think we have that command, right, to replace.
Yeah, that command is in strings.
Okay.
And here we have different commands. For a list, we have different commands. We'll see those. Okay, so next, similarly, player 1, player 2, player 3 we have. So if I want to modify player 2 with player X something, so I can modify that. So player 2 is replaced with player X. So this is how we can modify lists. So you can practice these tasks, how to modify a list. So this will give you some hands-on. Okay, so here are those methods. So how to add and update. So in strings, there are different methods. In list, there are different methods. So both are different data structures. So string is a different data structure, list is a different data structures. So string has different methods and a list also has different methods. Let's see them. Okay, so if I want to append, so append in the sense I want to add a number to my list. So what do? I can use this method, numbers dot append 4. So this is my number that I want to append to my list. So if I print my list here, so it will be printed 1, 2, 3, 4. Similarly, when I say numbers dot insert, okay, so what I'm saying, so whenever you append, it will append at the end. Append happens at the end of the list. So you can see here, when I added 4, it added at the end of the list. So now with insert, let's see what happens here. So I have 1, 2, 3. What I said, instead of 1, insert 1.5. So it actually replaced that value. Oh, sorry, it actually inserted value after 1. So after 1, we inserted 1 value. So this is how insert. So we are this is the default behavior of append. It appends at the end of the list. But using insert, if I want to insert an element after a certain item, then I can use that insert and insert it in a list. Next, I have pop. So what it will do, it will remove items from a list. So when I ran the first time, it removed number 3. If I run one more time, it will remove one more element. We should have removed now. Okay, so let me run it one more time. Pop 1. So if I give pop 1, okay, so this is removing based on index. Okay, so if I say numbers of pop 0, it will remove 1. Okay, so I think you have heard the concept of FIFO, first in, first out, last in, last out. Similarly, it is a default behavior of pop function. It's removing the last item first. So if you declare any index here, that value will be removed from the list first. Okay, so this is pop method. Similarly, you can use remove method. So remove, what it does, it removes. So 1 and 2 remain, 3 values removed. Okay, so remove, the difference between pop and remove is, for remove you have to give the it takes one argument, but default behavior of pop is it will remove the last element by default if you do not give anything, any index to it. So that is the difference between pop and remove. And we can sort a list. So this is the sort method, numbers that sort. If I say 1, 2, 3, so it's actually sorted. So if I say 4 first, and run it now. Okay, so it sorted our list in a ascending order. So next I have reverse a list. So I can do numbers dot reverse to reverse a list. Just say 3, 2, 1. So this is how these are the list methods. Okay, so if you want to see some samples with text based lists, so I have task, assignment, project, presentation, print. This is my list, and if I want to append one item to my list, I can say tasks dot append. Okay, I can remove one item from a list like this. So what is removed? Assignment. So we had assignment here, which is removed from the list, from the first place. Okay, so you can practice these list methods. So commonalities, this commonalities is with strings. So even strings indexes are also same. It works in the same way. Even lists also same way, but methods of lists and strings are different. So in strings, if you want to replace a string, you will say dot replace. But in list, that is different. So we don't say dot replace. Either we can insert or we can append or we can remove. So that is how it works in list. So we have to understand this difference also. So when we are solving some problems, first we need to check what type of data structure it is, whether it's a string or a list. And if it is a string, what methods I can use. If it is a list, what methods I can use. Okay. So similarly, we already seen in for loops, you can iterate over a list. So you can use for loops to iterate over a list. So I have city list, and if I want to use for loop to iterate over a list, and inside the list, if I want to write a logic, if city is Mumbai, then only print something like that, I can use for loops also. And similarly in shopping cart, so let's say I have added a list of items in my cart, I can run it, and I can add my further logic here inside my for loop, so that to write whatever conditions I need, I can print those. Okay, so you can practice all these to improve your hands-on on lists. Similarly, store marks of students and calculate average, create shopping cart and add remove items, manage to-do list, maintain attendance lists of students. So you can solve all these problems to improve your hands-on with lists. Okay, so here I bought this diagram to showcase what are the common operations. What I was talking about was uh, in these are the list operations so that we perform. uh, we have seen so far. So how to create a list, how to access a list, and how to define indexes of a list. If you are accessing list from beginning, if you are accessing list from the end of the list, and how to access list, how to slice a list, how to slice a list in reverse order, and what are the list methods, how to remove items from a list. So for adding items into the list, we'll use append and insert, and for removing items from a list, we'll use pop, remove, and delete also. So delete will delete the entire list. And we can use in operator. So we can use this in operator in for loops to find out like what are the uh, search, what are the list. I have a for loop and I have a list, sorry, I have a list of 3 to 4 items, and I have a text that I want to search. I can use in keyword. So I can use sort or sorted also I can use. So this will sort my list. So I can reverse, I can count also, count. So I can check index item of a list. So next I can copy a list also. Okay, so I can say dot copy. So this will copy my list. So let's see an example. So I have this list. List 1 is equal to list dot copy. If I say this, so it will copy my list to list 1. So I can print list 1. So this is how I can copy. Slicing we have seen, slicing in forward and reverse order. So you can clear. Okay, so you can clear a list also. List dot clear function can use. Then list, if you try to access that list, so it says list is empty. Okay, so these are all the operations or that we perform on a list. So if you go through this, these are all the operations that we have. Okay, so all these we have already seen how to do. So pop function we have already seen. Okay, so one more thing with pop is it raises an index error if index is out of range. So if you have mentioned something that does not exist, so here we have 0, 1, 2, 3, 4, 5, 6, 7. So if you mention any value that does not exist, it will raise an error. Okay, so remove, we have already seen remove also. Okay, delete, we'll see delete. So what does, okay. So delete can be used to delete slices of a list or the entire list itself, while pop only removes single element at a time. So delete can be used to delete two things, either a slice of a list or the entire list itself. So when I'm saying list is equal to this and delete of 0, 2. So 0 is my 1, 2. So what I'm saying 0 to 2 is here till here. So 1 to 2, 0 and 1. These two will be deleted. And they will
It's
not
deleting.
Yeah.
It is deleting like it's taking n minus 1, right?
Yeah, this is n minus 1. So
So that's
indexes
why
will
it is.
always be n minus 1. Is 0, this is 1.
Yeah.
So when we
So
say
it is
2,
printing from
1
3,
and 2.
3, 5, 6.
Yes. So what we are saying, first we are accessing the list and we are deleting that particular accessed list. So we are accessing 1 and 2 and then using delete function we are deleting it. So the advantage of delete function is we can either delete the entire list itself. So if I say del, then it will delete the entire list. So nothing is printed here. But when it comes to pop, we can remove only one single value at a time, one single element item at a time. Okay, so that is the difference. Okay, so that's all we had for lists. So if you have any questions, you can come up or we'll wind up for today.
No, I don't have any question.
Okay, then. So keep practicing these and do a hands-on. So this will be easier for you. So even the strings class, we had the exact same. Only the part that is changed is some methods are different, but indexing, all those, they are same, exactly same. So you can go through that also. It will enhance your hands-on skills.
Yeah, okay.
Okay. Yeah. Okay. Thank you. We'll meet tomorrow.
Thank you so much.
Okay. Thank you. Bye. Hello everyone. So welcome to day 9 of Python class. So today we'll be discussing about tuples and sets in Python. Okay. So let me go to workbook here. Okay. So today we'll be discussing what are tuples and what are sets, how they are used in Python. Okay. So tuple is an immutable ordered collection of items. So you might have remember in our first day we learned about data types. So what are the various different data types? So we have mutable data types and immutable data types. So in mutable data types we have lists, and in immutable data type we have tuples, uh, integer and strings. Okay. So this is what we are learning today. Tuple. So what is tuple? It's an immutable ordered collection of elements. So what is the meaning of immutable? So once you have created a tuple, you cannot modify after you have created it. So it's an immutable. Second is it's an ordered collection of items. Okay, so it can store mixed data types. So like list, it can hold integers, floating point values, and strings in one single list. Similarly, even in tuple, it can hold mixed data types in one tuple. But the difference between list and tuple is list is mutable. You can modify list, but tuple you cannot modify it. Okay, so next we will see how to create a tuple. So just declare a variable, and you can you can create a tuple using brackets. So these are the brackets that define this is a tuple. So let me make it little bigger. Yeah. Okay. So this is how we create a tuple. So why do we use tuples? It prevents accidental data modification. It's more memory efficient, and it can be used as dictionary keys. So we have another data type that is called dictionaries. So in dictionaries, we can use tuples as the keys of values. Okay, so we'll see that in another session. Okay, so next we have, so what are the kind of tuple operations we have? Okay, so let's see. So let's start with indexing. So even the indexing is same here. We saw indexing in strings, we saw indexing lists and in tuple. So they are all same in tuple also. So here you can see I'm trying to access the first element by calling its index. So this index of this tuple is 0. So this is 0, this is 1, this is 2. So when I'm saying my tuple of 0, that means I'm accessing the number 1 from a tuple. So first element. So similarly, if I want to access second and third element, I can just mention I can access it through index, second element. So that's how we can access. So same thing, this is same thing as how we saw in strings, how we saw in lists. So the difference you have to understand here, strings are also immutable. You cannot modify strings. You can even if you replace one string with another string, the memory address will change. And in tuple, it strictly does not allow to change or modify a value in tuple. So we'll see that here in further details. So here even in tuples we have indexing in positive and negative order. So see, the index starts from 0. So if you are counting indexes from the beginning from forward order. So it starts from 0, 1, 2. Okay. So, and let me execute this, run this. Okay, so this is my forward indexing. If I execute these three statements, so this is my tuple, I have declared it. I have three items in my tuple. One is apple, banana, cherry. So I'm accessing the first element by calling its index, which is 0. I'm accessing second element by calling its index 1, third as second index number 2. So if I run all of them, I'll get all of them. So this is how I can access a tuple with its index. Same way, if I want to access a tuple from the reverse order, from backwards, so I can say -1, my tuple of -1. So we'll be able to access the last element from a tuple. So like we saw slicing in string data types, list data types. Similarly, we have slicing in tuples also. So we can slice a tuple. So it allows you to access a range of elements. So we have same way, we have forward slicing and backward slicing. So if I want to do a forward slicing, index starts from 0. You can mention start and stop where you want to stop. And in slicing, we have uh, one more step called one more what about I can say one more uh, item called step. So apart from start, stop, you can step also. You can write how many steps you want to take. Do you want to take 1 steps, 2 steps? So likewise, you can define that also in slicing. So this will be applicable to strings, lists, as well as tuple. So let's see. I have a sample tuple. So it's letters A, B, C, D, E, F. Okay. So I'm doing a slicing. So whenever I'm doing a slicing, I'm starting it from 1. So where is my 1 here? So my index 1 is this one. So this is 2, this is 3, this is 4, this is 5. So this number, when I'm saying 1, so it will start from here. It will go all the way till here. And since our end will be always n-1, it will stop here. So it will bring only these three values. So let me execute our first print statement here. Okay, so it will bring B, C, D. Now let's execute our second print statement. Okay, so I'm just saying 3. So what does this mean? Bring everything but stop at 3 minus 1. So n-1. So that means it will begin from this letter A, B, C, and 3 minus 1 is 2. So it will bring all the way 3 letters. So this is how different ways we can access or slice a list. So we already seen this, but in terms of tuple, I'm showing you again how to do a slicing. So same way, we are starting it the index accessing from index 3 all the way. Whatever comes after 3, we are saying get all of those items. So let me run this D, E, F. Okay. Okay. Next we have print. So this is my start, stop, step. So this is my step. So we are saying at a step of 2, for every 2 step, bring me what is the value. So I'm not defining what is my start. I'm not defining what is my end. What I'm just saying is take 2 steps, and when you take 2 steps, whatever the value you find, just bring me. So here you can see. So first it started with A, then it take 2 steps, B, C. So after A, 2 steps will be C, then again D, 2 steps will be E. So here we don't have any step after this, so that's why it's not displaying this value. So that's how we can use steps. So in slicing we'll have three options: start, stop, and step. Okay, so same way, like forward slicing, we have reverse slicing. So this uses negative step values, that is minus 1. So we can see the same tuple. I'll copy it here. Okay, so if I say minus 1, so what we are saying, start from minus 1, go all the way, and it's actually a full reverse. So we already seen this in strings, how to do a reverse. We have seen this in uh, practice session, how to reverse a list. So same way we can reverse elements or items of a tuple in the reverse order by using this formula, you can say. So we are saying start from minus 1 and reverse, bring every letter in reverse order. Okay, so next we have what we are saying, accessing a tuple, and we are saying start from 4. So this is 0, 1, 2, 3, 4. So our 4 will be E, and what I'm saying is oh, okay. Right, so in reverse order our start will be here. Okay, so this is our start. So my start is here, end, and step. Okay, so what I'm saying, start from F, step one letter, and stop till 4. So from index 4 down to index 2. So where is my index 4? This is 0, 1, 2, 3, 4, and 5. So if I look at this in negative, so this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So this will be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. Okay, so from index 4 to index 2, from 4 to 2 start in a reverse order. So that's what we are saying. So reverse this index. So we have C, D, E, right? So what we are saying, reverse this items, bring E, D, and C. So that's what we are seeing with this formula here. So same way, there are a lot of ways we can slice and dice tuple. So same patterns we can access, we can do it in strings as well as in lists also. So for tuples, here we can see, if I'm running this command, let me comment this out. Okay, so my tuple of minus 2, my end, I'm not ending here, and I'm saying start from minus 2. So minus 2 will be E, I'm saying start from E, then step to negatively step 2 numbers. So it will skip this and go back to C. Again, what I'm saying, this is my step. So again, skip B and go back to A. So it's taking 2 steps in reverse order. So we can step in forward order as well as in reverse order also. So this is how slicing and dicing. Slicing works in Python. So we can use slicing in strings, lists as well as tuples. Okay. Okay, so here are some techniques. What are the types of slicing we can do? It's a forward slicing, slice from start. These are all techniques we have seen. Partial slice, full reverse, step slicing. All these we can do. Okay. Okay. So next, we'll move. So what all we can do? So in this session, we are seeing what all we can do with tuple. Okay, so we can find the length of a tuple. So I have a tuple with 3 items. So I need to find the length. So I can use length function, len. So len is a function. This is a predefined function, predefined Python function. So we can use this function to grab this variable and put it inside. That will count the number of elements in a tuple. So this is what it's doing here. It's bringing the length of a tuple. So we have 3 elements inside our tuple. Okay. So let's say I have a nested tuple. So in the nested tuple, so this is my 0. Combination of these 2 is my 1. This is at 1 index and this is at 2 index. So let's say I want to access just first element. So I will say nested, whatever the variable is. So I have declared the variable as nested. Instead of 0, I'll get 1. So when I say nested of 1, so when I say index 1, I get complete nested tuple. So we have a tuple inside a tuple. So this is the main tuple. Inside that tuple, we have a sub tuple. So I'm completely accessing this. Now let's say I don't want to access this complete tuple. I just want one value. So that I just want 2 from the subtuple. So what I'll say, again from this subtuple, if I define what are the indexes of this subtuple, so it will be 2, 3 would be again 0 and 1. So if I want to access 2, I'll say 1 and 0. Let me comment this. So this will bring me value 2. Okay. So similarly, if I want second element in the subtuple, I will say 1. This is how it will work out. Okay. So this is about nested tuple. Okay. So we already talked about immutability. So this is very important concept. Like it will come handy when you are doing a problem solving. What type of data structure you are using, it will come in handy when you are doing a problem solving, because tuples does not allow modification of a tuple. So let's see an example. What I'm doing, I have defined a tuple. It has 3 items inside it, 1 apple and 3.14. So what I'm saying, I'm accessing this particular item, that is apple. I'm modifying it with banana. I'm trying to modifying it. So let's see what happens. So so you can see it errors out. So what does it say? Type error. Tuple object does not support item assignment. So by default, immutability in tuple does not allow modification of its items or its elements. Okay, so if you have any questions, you can come up, or I can move forward with looping.
Questions.
Okay, sure. So, like we have seen loops in previous classes, we can loop through the various values. Like we can loop through integer values, we can loop through string values. Similarly, we can loop through tuples. Okay, so a tuple is an ordered immutable collections. So what we can do, if we have a tuple with the three values, I can write for I can declare a variable item and say in my tuple. So what I'm doing is directly I'm accessing my tuple and looping through it and just displaying. So I can write a condition inside my loop. If item equal to apple, then only display it, something like that. So in those kind of scenarios, let's say I just know as of now I have only three elements in my tuple. Let's say tomorrow I have hundreds and thousands. So it will be a lot of manual work to find out whether my condition matches or not. So in those cases, I can use for loop, iterate through my tuple, and write my logic and then print it. So this will be very much handy. So what I'm saying, this is my logic. So if item is apple, only then print it, otherwise not print it. So it will loop through all these values and then find out if it is apple, then print, otherwise it will exit. Okay, so similarly there are other ways of accessing or looping a tuple. So we can use length function. So what does length function do? It will convert a tuple into integer. So whenever we use length function, okay, so this is my tuple. So let me, okay, so this is my tuple. So I'm just printing it, and if I say type, what type is it? So type will get what data type this particular variable is. So what data type it is? Of tuple. So now what happens when I convert my tuple in and get the length? So let's see what happens. So I'll say I'll declare a variable called n equal to. Okay, so let me first run it. So it might be okay. So let me first run this length of tuple. So how many elements I have? 3. So it got number 3. So now I'll check the type of this. So it got converted to integer data type. Okay, so you can see we can convert our the tuple length into an integer, and whenever we are using integer data types, we have to use range functions. So range function works only with integers. So that is the reason why we are using range in our for loops. Okay, so this is the range function that we are using. So this is how I can access the length of my tuple. Then I declare my for loop and I say for I in range of my tuple, print whatever the index, and then I'm accessing my tuple's value here. Okay, my tuple of I is, it will be 0, 1, 2. So all these values. So we are looping through our tuple. So this is another way of looping through a tuple. Then next we can loop through a tuple using index and value. Okay, so by default a tuple will generate both index and a value. So if we see here, so if I execute my tuple, this is what I get. So when I say enumerate let me declare a variable, then print it, print a. Okay, so it stored everything as an object. Okay, so this enumerate function, it stored my tuple as an object. So this object will contain both index as well as value. So what I'm trying to do is I'm declaring two variables in my for loop, and I'm accessing those indexes as well as values from my uh, tuple. So when I'm saying enumerate, it will get both of them together. I'm just declaring these variables, so it will store index here and value here, and I will just print it here. That's it. Simple. So this is another way of looping through a tuple data type using for loops. Okay. Similarly, we can loop in reverse order. Okay. So for item in reverse of my tuple. So what is my tuple? Apple, banana, cherry. So this is in forward order. So it will just display everything in reverse order by using a reversed function. So this is inbuilt predefined function of Python. The same way, if I want to do the same thing manually, so I did it using Python internal function. But if I want to do it manually, I have to write using range functions. So in range function, I will define what is the length of my tuple, and I'll do a negative. Since I want to iterate from the end of the tuple, I'll say this is ending, and also say n minus 1. So whatever the number, take minus 1, then this is my n value, and this is my. So actually, if I say minus 1, it will add up. So this is how it is. So let me break it down so that it is clear. So length of tuple is 3. So if I say minus here, so it will become minus 3. And if I say minus here, it will become minus 4. So our value here will be minus 4, because we maintain same values in negative integers. Here you can see, right? In the negative integer, we start with minus 1. Whatever the value is last, we say minus 6. We don't start with 0. That is the reason why we are doing this. We are adding up a minus 1 value with our n value. So our n value will become 4, and my start will be minus 1, and step will be minus 1. So I'm saying start at minus 1 from the ending, step each one of the values, and go till minus 4. So this is how minus 1 cherry, minus 2 banana, minus 3 apple. This is how it will be printed. Okay. Similarly, we can use while loop with index to loop through a tuple. So I'll define I equal to 0 while I less than length of my tuple, print my tuple of I. So this is where I'm accessing my tuple. Then I'm doing an increment here. So in while loop, it is compulsory. We should increment the values. By default, it will not increment the values. For loop, it will by default increment the values with plus 1. So that is the reason why we have to write this statement here explicitly. Okay. Yeah. Okay. So this is how we can use while loop with tuples. So let's say I have nested tuples, a tuple inside a tuple. So I want to unpack these. So what I'm saying, this is my key, this is my value, key value pairs, combination of key value pairs I have. So what I'm saying, I want to unpack this and display on this format. So how I do is, I can use for loop for key comma value in tuples. I can just say tuples and I can access this key. So all those keys will be stored in key variable. All these values will be stored in value variable. So first time when it runs, it will print a equal to a is key and 1 is value. Second time when the for loop runs, it will print b and b2. Third time c and 3. So this is how for loop will get executed. Okay, so these are the various ways we can loop through a tuple. So one more important function with tuples is we can return a value in a function. So we have seen function classes, right? So in function classes, whenever we have a function, we return a value to the caller. So when we call the function, so here, where is the calling happening? We are calling the function here. So whenever the function calling happens, this function will go here. It will check, okay, whatever the logic, it will calculate it. Then finally it will return. Okay, so similarly, when I'm running this function, so it's returning the value x and x equal to 10, y equal to 20. So I'm getting those values and printing it here. Okay. So you can use tuples in functions to return multiple values. So let's say right now I have one or two values. Let's say if you have 10, 20, 30 values, so you can, in those cases, you can use tuple. So that will be faster for getting values from functions. The same way, you can get stats from a list. Okay, so this is my tuple. So inside the tuple, I can have a list. So what I'm sorry, this is my function. So inside my function, I'm passing a list, and when I'm passing a list, I'm getting the result as a tuple. Okay, so here you can see this is my function, this is my logic actually, and this is my calling. So I'm calling here and I'm passing this value. Okay, I'm saying, hey, get stats functions, take this value 10, 20, 30. So what it will do, okay, get me number 10, 20, 30. We'll take these numbers, sum it up, and do average total divided by length of numbers. So total is 10, 20, 30, 30 plus 20 plus 10, 50, 60. 60 divided by 3 will do it. Then it will return. So here what we are doing, returning total comma average. So when it's returning the value, it will return in a tuple. Then again, we can unpack this tuple here. We can take those two variables and whatever the result that this get stats gets it, we can store it here, then again print it here. Okay, so most use cases are we can use tuples in for loops and in functions to get the values quickly. And same way, so I'm using a function check order even, passing a value, it will get me the value in tuple. So what I'm doing, I'm unpacking here. So this is how it will work. Okay, so in short, what we can say, functions can return multiple values using tuples. You can access them by index or use unpacking. Great for returning group data like coordinates, stats, or multiple results. Okay, so if you write return AB, Python automatically wraps it in a tuple. So whenever we are writing this a comma b, right, return a comma b, so by default function will understand that, okay, I need to return this value in a tuple data type to the caller. So this is the caller, it will store it in this variable. So this is how default nature of return function when we say x comma y. Okay, So this is about tuples. So we'll continue with sets. Okay, so once this meeting gets ended, please rejoin it. Okay, so even sets are immutable. So the only difference between sets and tuple is sets are unordered, so they are not ordered. They don't have indexes like tuples, strings, or lists. So sets don't have indexes. And also, what are the features of sets? They are unordered, and automatically it removes duplicates. So whenever you convert a data type to a set, automatically if there are any duplicates, it will remove it. And elements must be immutable. So even in sets, elements are immutable. Okay, so why we use sets? For faster membership tests. So if this value exists in this or those kind of operation, for mathematical operations also we use sets. So let's quickly create a set and print it. So this is my set. So you can see curly braces. So my set is my set have curly braces. So now you notice I have 1, 2, 3, 2 times 3. But when I'm printing my set, it automatically removed one element, duplicate, and it printed just 1, 2, 3. Okay. So what happens if you try to access a set like we do with?
This meeting is being recorded.
Okay. So what I was saying, that we cannot access the set directly. So if I want to access set directly, I have to convert it to a list. Okay, so I can convert my set to a list using list function. Then I can access through a list. So what if I want to convert a list to a set? I can use set function. So set is a predefined Python function. Using that, I can convert my set to a list. Okay. So now we'll see what are the set operations. So what are the use cases of sets we saw? So we can use for fast membership tests and mathematical operations. So we might have read sets in mathematics, right? So in some of those chapters. So similarly, sets works in the same way. So if I want to add an element to a set, so I'll say my set dot add. So I'll mention what element do I want to add to my set. So I'm saying I want to add 4 elements. So I'll execute. So now my set has become of 4 elements. It has become a set of 4 elements. Now if I want to remove one element from a set, I'll say my set dot remove. It will remove one element from a set. So if I want to do a membership test, so if this number exists in this set or not, so those kind of. So what I'm saying, 3 in set. So this means is 3. Does 3 exist in set? So say is 3 in set. So it will answer in Boolean. So true or false. Yes. Now we have union operations. So these kind of union operations we will have in SQL also, and in mathematics also we have this. So if I want to union 2 sets, so the union will always bring unique. So what does union do? It will bring unique values only. So default operation of union is it will bring unique values only. So now I have 1, 2, 3, 3, 4, 5. So it should bring 1, 2, 3, and it should remove one more 3 and bring 4, 5. So if I execute set 1, set 2, and I'm saying set this symbol that you see, this is the meaning. This means we are doing a union operation. Okay, so this symbol denotes union operation. So you can see now we had 2 sets, set 1, set 2, 1, 2, 3, 3, 4, 5. But final result is 1, 2, 3, 4, 5. Okay. So similarly, we have intersection. So this concept we have in SQL as well as in mathematics also. So what does intersection means? Bring only the common values between two sets. So what are the common values? 3. And what else? We don't have anything. So it will just bring 3. So here and denotes and symbol in sets denotes intersection. Okay. So next we have difference. So if I want to find the difference between two sets, so I can use minus set 1 minus set. So it has removed the it has calculated the difference. So next, symmetric difference. So I have 1 2 3 3 4 5. If I want to calculate 1 2 4 5. So this is how these are all the mathematical operations we can perform in Python using sets. Okay. So let's see how do I loop through a set. So I can use for loops, right? So how do I use for loops? So I have my set here. So I have apple, banana, cherry. So notice we already discussed set does not have indexes. So if I want to uh, print, I can just print the item. I can just print the value. I cannot print index. Okay, so I cannot access individual item. Okay. So if I want to quickly compare between tuples and sets, so tuples are ordered. Okay, while sets are not ordered, and tuples have indexing. So it will have forward index, reverse index, while set data types they don't have indexing. So tuples they will allow duplicates, while sets does not allow duplicates. It will always convert uh, if you convert a list or tuple to a set, it will make it a unique set. So all the duplicates will be removed. So we can loop through tuple as well as sets, and whenever we insert any value in a tuple, it preserves the order. But in set, there is no order, so it may insert the value at any place. So there is no order. There is order is not maintained in the sets. Okay. So we have some exercises. You can go through this, try to execute these programs and see like how you are able to work with tuples and how you are able to work with sets. Okay. So now I have a final comparison chart here. So since we already learned list, we already learned tuple, we already learned set. So I have a final comparison chart to show what's the difference. How does it look? So this is how list looks like. So we have square brackets around it, and tuple we have no brackets, just the brackets, and sets use curly brackets. Okay. Now how do we create a list? We can just use this square brackets, or we can convert any of other data type to list using list function. Similarly, we can use open and close bracket to create a tuple, or we can use a tuple function to convert some other data type to tuple. And similarly, we can use open and close curly brackets to create a set, and we can convert another data type to set using set function. So these are predefined inbuilt functions in Python. These three functions are list, tuple, and set. Okay. So next, lists, they are mutable. You can modify an item from a list. You can replace 3 with 4. But in tuple, you cannot do that. It's not mutable. So it's immutable. And even sets are immutable. You cannot modify set actually. So let me check here quickly. Sets are also immutable. Okay. So list is ordered collection. So always list will be in it will be in order. So it will have an order indexes like 0, 1, 2, 3. If you are accessing in a forward direction, reverse direction -1. So even tuples will also have order, but set does not have order. List will allow duplicates, tuples will allow duplicates, sets does not allow duplicates. So you can do indexing with lists, it is supported, and with tuples also you can do indexing, but sets does not support indexing. You can do slicing as we have seen with list data type, and tuple data type also you can do slicing, but in list sets does not support slicing. You can access an element of a list by an index. Even for tuple you can access an element of a tuple by index number, but you cannot access a set through an index. Okay, so you can have nested collections in a list, and also in tuple, and in sets also you can have nested collection if the elements are hashable. Okay, so hashable as dictionary key. So hashable keys, they are not allowed in list, but it's allowed in you can make tuple as a key for another values. You cannot make this sets as a keys for another values in nested. So if you have nesting of data types, which we will see in further classes. So iteration, we have seen for loops or while loops. You can iterate through a list, you can iterate through a loop, you can iterate through a set. You can find length of a list, you can find length of a tuple, you can find length of a set. So what are the operations you can perform? These are the methods. In list we have append method, and since tuples are immutable data type, you cannot add, once you created a tuple you cannot add any other element inside a tuple. And here uh, let me verify this set. Even sets are immutable. Even set, okay, yeah, sets, even though sets are immutable, you can add uh, a value inside a set. So let's check it here, let's confirm it here. Set. Okay, so we have added a value to a set. We can add values to a set. You can remove element from a list, you can remove elements from a set, but you cannot remove an element from tuple. So this is the comparison. So you can do a membership test, you can do concatenation of lists, you can do concatenation of tuple, and you cannot do concatenation in the set. You can do some of the mathematical operations in sets. So if you want to do minimum maximum sorted, you can do with list and tuple, and also with sets. Math operations are not allowed on uh, lists directly, like union, intersection. In tuple also it's not allowed directly, but in sets it's allowed. So what are the built-in methods? These are the built-in methods in list: append, extend, remove, pops, insert, reverse, sort. And these are the built-in methods in tuple: count and index. These are the built-in methods in set: add, update, remove, discard, pop, clear. Okay. So conversion: how you can convert some other data type to a list using list function. And if you want to convert some other data type to a tuple, use tuple function. If you want to convert any other data type to a set, use set function. So this is how you can use. So finally, a quick recap: how does it look like? So this is a list, this is a tuple, and this is a set. Okay. So this is so far about tuples and sets. If you have any questions, you can come up, or otherwise we'll wind up this session. Okay, so we'll wind up. So if you have any questions, you can ask. We'll meet in tomorrow. So today we'll start with another data structures in Python. There are dictionaries. Okay, so far we have seen string data types, list data types, tuple, sets. Now there is another type of data type that is called dictionaries. So dictionaries, it's what is a dictionary? It's a collection of key value pairs. Okay, so yesterday we talked about tuples, right? So tuples can be used as a keys of value pairs for a dictionary. So the combination, you can use it. So that's what we have talked about yesterday. So dictionary is a combination of key value pairs. How does it look like? So you'll have a key and a value, key and a value. So every value will have a key. Okay, so let me start recording here also.
Meeting is being recorded.
So dictionary is a combination of key value pairs. So what are the properties of a dictionary? So it's an unordered, and its order is based on the insertion. So at whatever the order, at whatever place you insert, uh, it might be, inserted at whatever place you might insert that record. So it does not follow a strict order, like only after the end of the dictionary it should get inserted. Then it's a mutable. So dictionary is a mutable. So again, if we go back to our data types, and then what were the mutable and immutable data types? So we have strings, integer, and floating point values. These are immutable data types, even tuples. And coming to mutable data types, we have lists and dictionaries and sets also. So yesterday we saw about sets, right? So sets is also mutable, but there is one more concept in set called frozen set. So if we have a frozen set, that will be immutable. So that means if I freeze set values, that is immutable. So this is how uh, data types are distributed between immutable and mutable. So why dictionaries are important? So there are three reasons we can look at. So it acts as a fast lookup. Then we can store structured information in a dictionary, and I can use a dictionaries for APIs. So generally what happens is, as we human beings, we understand data in a tabular format, but when come to programs, they need they follow a specific structure. So they understand data when you give them in a proper format. So that would be either list, either tuples, or dictionaries. So we pass these information from one application to other application using these data structures. So that's why these data structures such as list, tuples, dictionaries, they are very important. So one program can interact with another program using this data structures. So one of them is dictionaries. So we use dictionaries for API, application programming interface, or if you want to set up configurations of any application, so we can use dictionaries. Or if I want to store user data, I can use dictionaries. So let's start with this. How do I create a dictionary? So in our previous sessions, we saw how to create a list, how to create a tuple, how to create a set. Now here we'll see how to create a dictionary. Okay, so now what we said, dictionary is a combination of key value pairs. So I will have a key and its associated value. I will have another key and its associated value. So now let's come down here. Okay, so name is my key and value is Alice, and age is my key and its value is 20. Grade is my key, its value is A. So this is how a list. Okay, so you might have noticed yesterday we used sets, right? Sets also uses curly brackets, but the difference there is, so the sets are totally different data sets. It does not allow duplicates. It will automatically remove duplicates, and it does not use these key value pairs. So dictionary, it uses, like, it does not have indexing, so it will consider name as its index. So let's see, how do I access values in a dictionary? Okay, so if I want to access the name of a student, I have to call the key. What is the key here? This is the key. I have to call by its key. This is the key. This is the key. This is the key. So this is key 1. This is second. This is third key. So this is how dictionaries are a key value pair. So if I want to print the name Alice, if I want to access the name Alice from my dictionary, so I have to say student of name. So this is how I can access. So if I say, so this is my dictionary, it's stored in my student variable. Okay, so I can check what type of data type it is using type function. So it says it is a dictionary. Next, what I'll say, student of name. So when I say this, what it will access, it will access the value of my key. So what is the value of my key? Alice. This is value. So using keys, we are able to access its value. So this is how it works in dictionaries. Okay, so there is another way to access values from a dictionary using inbuilt get function. So we have a get function in Python. So what I'll say, student dot get, then I'll define my key. So what is my key? If I say name, so it will get Alice. So dot get is a safer way to access dictionaries. Why? Because we'll see in the below slides. Okay, so moving to next slide, let's compare list with dictionaries in a way that we'll understand how does it differ. So because we are learning a lot of data structures, right? So to avoid this confusion, so I'm always comparing list, because lists are easier to understand, so that we have good understanding of how these data structures differ. So in list we are indexing, right? So from if you are indexing from the beginning, it will start from 0. If you are indexing from the end, it will start from the negative integers. But in dictionaries there is no such thing. So we don't have indexes. We don't access dictionary by its position. Okay, so can we do slicing with list? Yes, we can do slicing of the data. So if I say 1:4, then it will bring that particular set from my list. When it comes to dictionaries, there are no slicing. Slicing is not possible. And how do I access list? We'll access through index integer. So whatever, where it will be positive integer or negative integer. But when it comes to dictionaries, I will access it through the key names. So the key name can be uh, key value. So here we have seen my key was name. So uh, I accessed it by name. So when it comes to order, lists, they are always ordered. So from version 3.7, dictionaries are ordered, but based on keys. So they are always ordered based on keys, not on indexes. So unlike lists, they are always ordered based on their indexes 0, 1, 2, 3. But dictionaries are ordered based on their index, their keys. Okay, so this is the key difference. So that way you will have a good idea how do these data structures differ. Okay, so now let's see a sample example. Okay, so in list, if I have a list apple, banana, cherry, so if I want to access apple, I'll say fruits of 1. So it will bring my value at one position, that is banana. But when it comes to dictionary, if you try to access in the same way, what happens? It will raise an error. So if I say student of 0, then it will raise an error, key 0. So that means there is no key called 0. That's what it's saying. So what is the key here? Key is name. It will bring. Okay, so I'll revert this back. Okay, so this will error out if we try out. Okay, so we can access dictionaries by its key. Now what are the methods? So in our previous sessions, for strings, for lists, for tuples, we saw there are some methods that we can use. So similarly, there are some methods with dictionary also. So here is a quick comparison table to show what are the methods that we had in list and what methods we have in dictionaries. Okay, so in list we have append, insert to add certain item, but in dictionaries we can directly add a new key value pair, or I can use update function, inbuilt function, to update a dictionary. Or if I want to remove item from a list, I'll use pop, remove, delete. Same way I can use pop, delete, or pop item in dictionary. So these will uh, work based on their default behavior. So I can use in operator to search certain value in a list. Same way I can use in operator. So we can it will so in list we can directly check the value, but in dictionary we cannot check the value directly. So if we can use in operator, so this will do a check of keys only. We can do a check of keys, then again we have to write one more function, one more logic inside it to check the values then. So that's how it will work. This is the difference here. So we have sort and sorted functions in a list. So that will, if we write sort, we can sort a list by ascending or descending order. Sorted means by default it will sort the entire list in ascending order. If we have 1, 2, 3, 4 in jumbled orders, it will it sort that list into 1, 2, 3, 4 in ascending order. So no direct sort method, must sort keys manually. So we have to sort the keys manually here in the dictionaries. So we can reverse a list and using reverse inbuilt function in the Python. But when it comes to dictionaries, there is no direct method to reverse the keys. We have to reverse the keys manually. Okay, so we can copy a list. Same way, we can copy a dictionary to another variable, and we can find the length of a list. Yes, we can use length function to find the length of a list. Similarly, I can find the length of a dictionary. So it will take the keys, only keys. It will count how many keys it has. So when we do length of whatever, I mean, a dictionary we have. So here, if I say length of student, my student dictionary, then it will count the number of keys inside the dictionary. Okay, so these are the comparison table. So that way it makes our understanding clear between these data structures. So what are the different ways to access dictionary? So one, we saw that I can access it through the key. So what are my keys? Name is my key, age is my key, grade is my key. Okay, and you notice a dictionary is also is created using open and close curly brackets. Okay, so whatever comes before my colon, it's a key, and whatever comes after a colon, it's a value. Then comma. So this is my one key value, this is my another key value. So same way I can add multiple of them. So now let's see, using get method, how I can access our dictionary in different ways. So what is the get method? The get method is used to safely access the value of a key in a dictionary. So if I want to access the value of a key from my dictionary safely, I can use get method. So how is it safe? Why student of name? Why is it not safe? So let's look at that. Okay, so if I type student of get of grade, student dot get grade, so grade key is available. Yes, it's available. Let me run it. So it's giving it. So if I say, if I give a random key which is not available, so it says none. So this is a safer way to access. But in the same way, if I say, student of grade, so I'm accessing with direct key access. So I'm accessing its value by directly using a key. So I said this, I got the value. If I say grade 1, so which is not available in my dictionary. So if I run it, so it will error out. So what error does it say? Key error. So there is no key called grade 1. So that's the reason why we are saying dot get method in dictionaries is a safe way to access. So why is it safe way? So dot get method is used to safely access the value of a key in a dictionary. If the key exists, it returns value. What if it does not exist? Then it returns none, or you can throw an exception. So you can say, if the key does not exist, I will have an option to give a default value. So let's say marks key is not available. So if marks key is not available in my student dictionary, so by default I'm displaying this n not available, or you can say n a, something like this abbreviation. Okay, so next, okay, so this is completed, right? Okay. Okay, so next we have keys method. So we can access a list using keys method, dot keys. So I have this dictionary student, and this is my key, this is my value, key value, key value. So what I'm saying, print student dot keys. So let me comment this out for now. So if I run this, so it's bringing all my keys only. So here you can see, and so it says dict keys, so it means dictionary keys. So name is a key, age, grade. So I can add one more subject, maths. So automatically it took this one more key as subject. So same way, let's say if I want to loop through my keys, I'll use for loop. So for key, so this I defined as a variable. Key is my variable in student dot keys. So this is my method. So this is my dictionary student, which is here, and I'm saying dot keys. So dot keys, what it will get, name. So I'm looping through all these keys. Okay, so let me run this now. Okay, it looped through all the keys and got me the key names separately. What is the name of this? What is the key name? Name. What is the key name? Age. What is this key name? Grade. What is the key name? Subject. Okay, so this is how we can use keys method. And there is one more method called values method. So this values method is used to get only the values from our dictionary. So I have a dictionary called student, and in this student dictionary I have key value, and key value, all three key value pairs I have. So in this key value pairs, what I'm saying, I just want the values. I'm concerned about getting the values. So in that case, I can use dot values function. So similarly, you can notice here, we can print dot values. It will get me all the values inside a dictionary. So same way, if I add one more key value pair here, then it will get me another value also. So those values, I'm unpacking them. So I'm just displaying it separately here. Alice 20A maths. So now we can combine these keys and values together. Okay, so we'll see that also. So now there is one more method called items method. So we can use items method to grab both key and value at a time. So let me just run till here. So this is my dictionary. So what I'm saying, dictionary dot item. So whatever items I have, just display it. So when I say that, so it says dic underscore items. So you can see here, I got this is my list and this is my tuple. So it shows these values in a tuple. Here you can see tuple dataset. So there is a this tuple inside a list. So that is how it displays. So now what is the first one? It's a name, its value. So it combine each of these key value pairs in a tuple. So first key value pair in one tuple, second key value pair in another tuple, third key value pair in another tuple. So now what I am saying, so I'll go to I'll write a for loop to extract this key and put it here in my web. So key is my variable I'm defining here. So whatever keys are there, I'll take in key variable. So whatever its associated values there, I'll take in value variable. Then finally, I'll use print statement to print those in a loop one by one. So finally, when I run this, so this is how you can see. I picked name from the tuple here, and I picked value from here and printed it here. So then again I went into another iteration of for loop. Then I picked age and printed value 20. Then I picked grade and we printed its value a. So this is how it will work out. So list, you can use items method to loop a dictionary. So this is very important methods, because accessing a dictionary is different than accessing a list. So lists are simple, but dictionary, so we have to use these methods to access it easily. Okay. So same way I can use for loop to access a student values and print keys also. So how can I do that? Just by key, you can notice here I am using for loop for key. So key is my variable in student. So I'm checking, check keys in my dictionary. Okay, use that key, and what I'm saying, student of key. So it first it will go iterate student of name, student of age, student of grade. So it will iterate every time name, age, and grade and bring its value here. So it will bring the keys from this variable and we are printing it here. So this is how it will loop through and print this. So this is another way we can use for loops to iterate over a dictionary. Okay, now I can use the same method to check if any key exists in my dictionary. Okay, so we talked about this topic at the start. Like in list, you can directly check whether this value exists or not in a list. But in terms of dictionary, you cannot check whether Alice exists in this dictionary. You have to check whether this key name exists in a student. Then again, you have to write another nested um, a statement to check whether this value Alice exists in the dictionary. So that is how it will work in dictionaries. So what we are saying, if name, so is the key name, is the key called name available in student dictionary? So that's what we are asking it. So just checking it, yes, name key exists. So if I just print here, and if I can write else here, it will go to my else statement. Okay, I need to give colon and print it. So see, I have changed the key name and it says no, the key name key does not exist. So I'm just saying no. So this is how it will work. So now we looked at how to create a dictionary, how to access values from a dictionary, how does it differ from a list, and now let's see how to modify a dictionary. Okay, how to add also we have seen. So just you can add another key value pair and dictionary values will be added. Okay, so now let's see how to modify dictionary. So since dictionaries are mutable data type, you can modify it. So how can I modify it? So let's say I have age 20, I want to modify it to 21. So I'll first access that dictionary using key student of age is equal to 21. So this syntax would be student of key. So what is my key? Student of age is my key. So I'm putting a key here and giving a new value, and I'm saying student of city. City is not here, so let me write. Okay, so so another way to modify, like if the value does not exist, I can define it here and add it in my dictionary. So you can notice here we don't have city here, so I'm adding it, updating my dictionary. So I have updated the dictionary the age from 20, it became 21, and city did not exist in my dictionary, so I added city also and its value. Okay, so next I can remove items from my dictionary. So when I say student dot pop, and it will remove the grade. So let's bring that bring our dictionary here down so that we can notice it. Okay, so this is my dictionary. So it removed. So let me print my dictionary one more time. Print student. So now you can see this complete key value pair is removed. So what is the default behavior of pop? It will remove the last item from a data structure. So whatever the last item, it will remove it. Okay. Or you can specifically mention it. So let's say if I do not mention, what happens? Let's check it. Student.pop. Okay. So it expects at least one argument. Okay. So in list, you can see in list, there the default behavior was, we even if we do not give, it would automatically remove the last element, but that's not the case with dictionary. So we have to give what you want to remove. Okay, so I say I want to remove grade. So similarly, if I say I want to remove age, so it is expecting at least one argument. So I can say I want to remove age. So this is how we can do it. So from this dictionary, so let me copy this dictionary here. Student equal to this, and I'm saying delete city, delete student of city. So I'm accessing the dictionary by its key and deleting that particular key value. So now when I finally print it, so I'm seeing this does not exist, city does not exist. Okay, so far we have seen dictionaries. Now here I have another example called nested dictionary. So here you can see, now we saw an example of student. Now what if we have lot of students? So again, it's a nested key value pair. So this is my key, this complete dictionary is my value. Okay, so this is called nested dictionary. So this is my key, and complete, this is complete, starting from here, this complete dictionary itself is my value. So this is called nested dictionary. Okay, so in this case, how do you access student 1 name or student 2's age, student 3's marks? How do you access them? So we can use double square brackets after. This is how I can access. I can use double square brackets. I can say students of, okay, this is main key. I'll access first, I'll type main key, then type sub key. So this is the syntax. So what I'm saying, students of, what is my main key? Student 1. So in students 1 record, I want the name of the student. So then it will bring Alice. Okay, so there is a typo error. Students is not okay. I need to run this particular. Okay, so I ran this. Now students dictionary is declared now. So let me run this print statement. So now you can see we got Alice. When I run this, we got Alice. Okay. So same way, I am saying, I will say I want student two's marks. Then I can get student 2 marks. So what is student 2 marks? 90. So that is how I can access nested dictionary through supplying main key and sub key in the variable. So how do I print how many keys, how many main keys I have? So I can use for loop for I in students. So students is my dictionary and print. So it will print all of the main keys here. The same way we saw that items method, right? So I can use that item method student dot items to print what are the keys available. So another way of doing it. But now let's say I want to print both key and values. So how do I do that? So same thing, I can use the same method student dot items, grab whatever key comes from these items, grab it in the key variable, value grab it in the value variable. Now print them in the for loop, print key and access value. So here you can see we will get value. What will be the value? Value will be the complete dictionary. So again from that dictionary we are accessing that individual key values from that dictionary. So this is how it will look like. So what if you don't what happens if you don't access value of name, value of marks, value of age? So this is how it will look like. So it will bring complete dictionary. So let me exclude all these and run it. So you can notice here, this is my key, this is my value. It's bringing complete dictionary as a value. So now what I'm saying, by using these print statements, value of name. So what I'm saying, value of name bring Alice only, value of age bring 20, age 20 only, bring marks only. So again I'm saying unpack these from a dictionary. So when I run this, this is how it will look like. So this is the different ways to access nested dictionaries. So now if I want to filter a certain data, like bring a dictionary key, I mean name, age, marks only if student's age is greater than 20. So I can write if condition in my for loop. So again, going back to our conditional statements, this is how we combine for loop and conditional statements and just print it. Okay, so this is how we print this. Now for key comma value in student dot item. So if I want to check any other key, like if I want to check marks, only if marks greater than 95, bring all those student names and their details. So this is how I can write it. So these are the students who have marks greater than 85. Okay, so the same way. So what I was talking about was so um, for this student dictionary, so I can say I can grab student ID key and student values in student info variables, and I can print them here. So I can print them in this format like student and its info.name, info.age. So this is how I can print student details if student marks is greater than 85. So these two, like here, whatever we write after for loop, the key value. So these are just variables. You can change them also. So here you can see I wrote the same thing, but here it's student ID and student info. So next we have same nested data structure. So I can combine everything. So I can write this data structure, nested data structure, I can write this for loop. So this for loop, I'm saying if age greater than 20, only get student details. So I can run this program. So it will get all of those student details whose age is greater than 20. So that's all for today for dictionaries. We will, so here are some practice problems. So what you do is create a student database with name and marks, create a product catalog with item and price, create an employee record with ID and profile. So create these dictionaries and practice these problems. Check if product exists or not. So how do you update marks of a student? How do you remove an employee? Print all product and prices. How do you access nested dictionary values? Okay, so these are the problems you can solve. Okay, so to quickly recap, dictionaries are a combination of key value pairs. You can have nested dictionaries. There is a you can access dictionaries through its keys only, and it's a mutable data type. Okay, so that's it for today. We'll meet on Monday. Thank you. Hello everyone. So today we will see list and dictionary comprehensions in Python. Okay. So what are comprehensions? So a comprehension is a short and elegant way to write list and dictionaries in single line. So that replaces the for loop, multi-line for loops. Okay. So here you can see this is the definition of comprehensions. Okay. So how do you write comprehension, list or dictionary comprehensions? So here is the tip. So first you can write regular for loop, then you can convert that into a list or dictionary comprehension step by step. Okay. So let's see sample. If we do not write a program in list comprehension, how does it look like? So in regular loop, this is you can see. So if I want to find a squares of a particular numbers from 1 to 6, this is how I write in my regular program. So let me copy this program and so let me run it here. So this is how first I'll declare. So I want to capture my output in the squares variable. So that's why I have to declare the squares variable list here. This is an empty list. So once uh, I have declared an empty list, so I'll calculate uh, the list of squares by using squares dot append. So every time it generates a square, it appends my list. Okay, so here I have created my empty list, so I want to append my empty list every time for loop runs. Okay, so let's run this program. So here we can see, so 1 square 2 1 square 2 is 1, 2 square 2 4, 3 square 2 3 square, so list of squares. So here you can say uh 3 square 2, yeah, 3 square 2. So I value, so this I value will change every time. So this it will find the squares. Okay, so the same program. So if I want to write the same program in comprehension, so how do I write it? So this is how I write it. So here is the syntax. No, I'll say expression. So what is my expression? So my expression is logic. So what is my logic? I into star. So this is my squares logic. Then I'll declare my for loop for I in range 1 to 6. Then with just single lines of code, I'm able to calculate list of squares, and I do not have to declare my squares variable separately. With this same variable squares, I'm able to calculate and print it. So let me run this list of squares program here. Okay, so here we can see we got the same result. So with just one line of code, we have found out list of squares. Okay. So going back to the definition, so what is comprehension? A comprehension is a short and elegant way to create list or dictionary. So here you can see we already saw what is list data type. We already saw what is dictionary data type. Now we are seeing what is list and dictionary comprehension. So in single line, we are replacing multi-line for loops while writing list and dictionary comprehensions. Okay. Similarly, I can write dictionary comprehensions. So if I do not write dictionary comprehensions, how does it look like? So this is how it looks. It looks like so. This here I have created an empty dictionary, and then I'm writing a for loop to loop between numbers 1 to 5. Okay, then I'm writing my logic here, then I'm printing the result here. Okay, so how many? 1 2 3 4 to the 4 lines of code. Okay, so let me execute it. So every time I calculate my result, I'm appending my result to my empty dictionary. Okay, so let me execute this. So this calculates along with key value pairs. We got the result. So square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, square of 5 square 2 is 25. So this is how we got. So if I want to write the same thing in just one line of code, so this is how I can write. So here is the syntax I can use. I can declare the expression, key expression and value expression. So I'll define two things here. So first I have to define what is my key. I is my key, and value expression, this is my logic, actual logic, which I have to calculate squares. Then I'll write my for statement for I in range 1 to 6. So this is just simple dictionary comprehension. So when I run this statement, so I get the same result. So with just one line of code, I'm able to create a dictionary of squares. Okay. So when do we have to use comprehension? So when to use comprehension? So let's compare. Okay. So in regular for loops, we have to write more lines of code, whereas in comprehensions, it's concise. We have to write just less, one line of code. So very less, or 1 or 2 lines of code. So if we have 2 operations to perform, and performance wise, regular loops, they are little slower compared to comprehensions. It's slightly faster. So we'll see why it is faster also. And readability. So in terms of readability, the regular loops are easy for beginners, but as you move on to write advanced programs in Python, so once you get familiar with the comprehensions, so this comes very much handy. So with just one line of code, you will be able to do a lot of things. So you can write list and dictionary comprehensions. So what are the use cases? So in regular loops, for loops, while loops we write, so it is used for building complex logic. But when you have to use comprehensions, when you have to perform just 1 or 2 tasks, like here I'm saying cleaning or filtering and transformation. So if you want to clean the data, filter the data, or perform a transformations on the fly. So with if you want to perform less logic, you can quickly write list or dictionary comprehensions. Okay. So here are some example. Okay, so I want to filter even numbers from a list. Okay, so how I do it? So I can write complete statement here in just one line of code. I'm able to filter even numbers. Okay, so you can notice this is my events variable, and what I'm saying, this is my for loop x. So this is my expression. So whatever the result comes from here, I'll capture this in X, then finally I will print it. I'll forward it to events variable, then finally I will print it. So this is this X variable will capture all the result that the right side part will generate. Okay, so what I'm saying, X, I'm defining X. So I'm saying capture everything after it executes. For X in range, so I'm declaring my X variable in for loop. For X in range 1, 11. So loop through 1 to 10 numbers and find out if there are any even numbers. So as we know the logic of modulo, right? So if my number modulus 2 equal to 0, that means anything divisible by 2 we consider as even number, right? So that's the logic we wrote here. I hope you remember the conditional statements we learned. So we use the if condition here inside the for loop. So here you can see this is for loop, and inside the for loop, this is how we wrote if condition. So in regular uh, program, this is how you write x equal to 0 for I in range, for x in range 1, 11. Then go back to the next line. If x modulo 2 equal to 0, print even. Okay, or print x. So in regular program, this is how we write it. So but here you can see in just one line of program we are able to calculate this. So if I execute this and say print events, we will be able to print the list of even numbers. Okay, so same way, so I have a dictionary along with the word length. So if I want to quickly find out what is the word length of a dictionary, I can quickly write a dictionary comprehension. Okay, so I have to close my dictionary here, dictionary comprehension here. So here you can see we are able to calculate it. So if I want to print it here, I can write word length. So it will calculate how many times apple, banana, cherry, how many times it occurred. So here what we are saying, word and sorry, we are not saying how many times. So we are saying what is the length of this text, apple, banana, cherry. So this will quickly calculate the number of characters in a word. So same way, for data cleaning, we can quickly use list comprehension. So I have a list of user inputs, name, an empty space, and none, Alice, again an empty space, again letter, again a word. So if I want to strip an empty spaces, so for data cleaning, I can use this. So I can write this program. So this is my user input. So this data is not clean. So it has empty names or empty spaces or none. So what I'm saying, just clean it. So if I output this cleaned variable, then you can see, so all empty names or empty variable spaces or nones all got eliminated. So that's what x dot strip means. So it strips those dirty data. Then along next use case is data transformation. So if I want to do a quick data transformation, so like I want to round the price of an item, then I can quickly do that. So here is my dictionary, and here is my dictionary comprehension. So what I'm saying, item, this is my key, this is my value expression, this is my logic. So here I'm calculating through for loop dot item. So we have seen these dot items method in dictionary while we are learning dictionary, right? So it will output both key and value pair. So we'll capture those, and then what we are saying, price into 83 at 2 decimal places. So if I print this, so you can notice we're quickly able to transform our data. So I'm saying apple 83, banana 41.5, milk 166. So this is how it works. Next, so if I want to do a log analysis, then see, so here is my log. So my log has these keywords. So info is my info, okay, error, disk full, info, running, error, timeout. So what I want to do is I want to get all those keywords that starts with errors, that starts with keyword error. So what I will do, I will write a list comprehension. So this is my line variable. So I'll capture all that will generate from here into line variable, then pass it on to the errors variable. So now if I run this program, so you can see it bought two list items here. This one, error disk full, error timeout, from my exact list. So these are the use cases of list and dictionary comprehensions. Okay. So now why comprehensions are better? So why they are better? So you may have noticed that for regular for loops we have written 3 to 4 lines of code, but for list comprehensions with just one line of code we are able to execute the logic. And readability, in terms of readability, so it's medium, that you have to read lines of code one by one, but in terms of list comprehension, it defines a simple logic, and it defines that you're writing a program in just one line, and you know more about Python's actual way of coding, Pythonic way of coding, writing Python programs. Performance. So in terms of performance, so traditional for loop, so it's slightly slower, but comprehensions, they are faster because these are developed internally. They are optimized in C language. So you might have remember in our very first class we discussed about bytecode, machine code. So C, C is assembly language code. So it is a compiler program. So once the code is compiled, so it will quickly run on the machine. So there is no need of interpreter. So when it comes to Python, whenever you run Python, every time it checks your syntax is correct, and your it will convert that code into bytecode, then bytecode is converted into machine code. All those process will happen. But in terms of C, as soon as you compile the program, directly it will create a machine code, and it will run directly in the CPU. So that's the advantage. So it makes our code run faster. And we have declarative style in for loop. So there is no declarative style in for loop, but when it comes to list or dictionary comprehensions, it's a declarative style of writing. So, and there is no functional approach in for loops, but when it comes to list or dictionary comprehensions, so it's a functional way of writing the code. Okay, so I think so far it's clear. So let's see a simple example, performance wise, how traditional program is slower and comprehensions, list or dictionary comprehensions, are little faster compared to traditional program. So okay, so here is my simple program. So I'm capturing the execution time of my program by writing this start is equal to time dot time. So after executing my program, I will minus the time from the print time. So whenever I'm printing the output, I'll minus that start time and I'll bring the loop time. Okay. So let me execute it. So this program takes 0.4 seconds to generate this output. with traditional for loop. So I'm trying to find the list of squares from 0 to 1 lakh numbers. Okay, so same thing, if I try to execute through list comprehension, so you can see I can, it takes 0.2 seconds. Okay, so this is the difference performance wise. List comprehensions, they are faster for the same amount of data. So you can see lag. Okay, so okay, so to summarize, list comprehensions, they are cleaner. So in one liner code you can write common patterns, and it's faster executions because it's internally optimized in C, and it's more Pythonic way preferred in Python community. So it's more Pythonic way of writing programs, and this less error prone. No need to declare initialize empty lists or dictionaries. So as you have seen in our first program, in regular way we had to declare our empty list to capture the output, right? But when it comes to list comprehensions, we didn't declare any empty list, just we calculated our logic and captured in the squares variable. Okay, so here are some programs we can execute and see. So let's see some exercises. So I'm creating a list of squares for integers 0 to 10. So this is my list comprehension. So it will quickly create for numbers 1 to 10 all the squares, and find all the odd numbers from 1 to 20. So it will find all the odd numbers from 1 to 20. Here is my logic that gets that odd numbers. Okay, so generate a dictionary where keys are integers from 1 to 5 and values their cubes. So this is my dictionary comprehension. So with this I can generate keys are keys increment by one number, and values are their cube. So values always cubed in cubes. So 1 cube, 2 cube, 3 cube, 4 cube, like that. So generate pair I comma j for I in 1 to 3 and j in 4 to 3. So here we are doing nested for loop inside list comprehension. So here you can see we are capturing our nested for loop in two variables. So first variable data will capture in I, second whatever it generates will capture in j. So I can create list of pairs. Okay, generate pairs 1 I comma j for I in 1 to 3 and j in 4 to 6. Okay, so next exercise we have is replace numbers divisible by 3 with fizz and by 5 with buzz in 1 to 15. This is my range 1 to 15. Within this range, if any number is divisible by 3, I have to replace it with fizz. If any number divisible by 5, replace it with buzz. So this is how it will work. So I can also create a dictionary with parity labels for numbers 1 to 10. So here's my key and this is my value. So here you can see I have started with the logic. If my number is divisible by 0, I'm considering it as even. So what I'm saying, even. So my number is even if. So this is other way of writing. So even in regular programs we write our condition after the condition, but here in list comprehensions we can even write before the condition. So what I'm saying, even, my number is even if, it's a English way of saying. So my number is even if my number is divisible by 0, else odd. For what are those numbers? For I in range 1 to 10. So this is how it generates. So list of prime numbers between 1 to 50 using list comprehension. So I can get list of prime numbers. So this is like in just one line of code I was able to write the complete program. So here you can see what I'm saying, x for x in range 2 comma 50. So what say we want prime numbers between 1 to 50. So starting from 2 and 51. So if so this is my condition that exactly gets me list of prime numbers. So if all x, so this is my membership operator. So what I'm saying, if it is divisible by if the divisible number not equal to 0 for in this range, and integer of x into 0.5 plus 1, so I can use this formula to generate the list of prime numbers between 1 to 50. So here I have created a nested dictionary. So I want outer keys 1 to 3 and inner keys between A to C with product values. So how can I do that? So I'll declare nested dictionary here. So I have I. So this is my key and this is my value formula. So this formula that will get me the values. So whatever the values that I am desiring for. So I want values from A to C. So what I said, I in my values logic, get me values from A to C. So I'll get values from A to C. So this is A one. One is my key, and A 97, 98, C 99. So this is how I'm able to get uh, inner keys with product values. So along with the product values also I'm able to get it. Okay, so next, so this is the last exercise. So what we are saying, generate tuples. So tuples in this manner. So x square, x cube, so on for 1 to 10, excluding numbers divisible by 2 or 5. So here I'm generating tuples. So what I'm saying, so here is my logic, x double star 2, x double star 3. So this will square or cube for what are those numbers 1 to 10. Then this is my logic. So what I'm saying, exclude numbers divisible by 2 or 5. So here I'm excluding numbers divisible by 2 or divisible by 5. So here I can generate list of tuples. So this is my list of tuples. So just with one line of code, I was able to do all of those things. Okay. So in short, uh, list and dictionary comprehensions is a short and elegant way of writing programs in single line, replacing traditional for loops. Okay, so that's it for today. We'll meet tomorrow. Thank you. Hello everyone. So welcome to today's session, which is nested data structures in Python. Okay, so far we have seen strings, lists, tuples, dictionaries. Okay, so now today we are going to see nested data structures. Okay, what are nested data structures? A nested data structure is a data structure that contains another data structure as its element. So this is useful for representing complex data, like for example JSON data, so for API communication, for tabular data, and for hierarchical data. Okay, so why nested data structures are used? Let's look at some of these reasons. So one of the reason is to model real world hierarchical data. For example, users with multiple addresses, to handle JSON responses from APIs, and to group related data together. Okay, so one more is to perform efficient data processing and lookups. Okay, so uh, we already seen, as I have discussed, that we already seen lists, tuples, dictionaries. So now we are going to see advanced data structure, that is one data structure inside the another. So that is nested data structures. So what are the commonly used nested data structures? So here is the list. So some of the commonly used nested data structure is, one of them is list of dictionaries and dictionary of lists, dictionary of dictionaries, lists of lists, and lists of tuples. So you might be thinking, what are these? Let's see how do they look like. And so before seeing how do they look like, let's talk about a real world example of in our day-to-day interaction how these nested data structures come into play. Okay, so so let's consider a food delivery app. Okay, so you have opened Zomato or Swiggy, any one of the food delivery app, and you search pizza in the search box. What happens in the backend? So in the front end, you see the results, so list of all the restaurants, then you click on one restaurant, then it shows list of all the types of pizza and its prices, what are the ratings of the restaurant, and where it's its location, all those details you'll see. So in the back end, what does it happen? As soon as you type pizza, the request goes to the server. So the request, what is the request? The get request. So this is the get request, it will go to the server. Then the server will respond in the nested data structure. So here you can see it will respond with pizza, restaurant name, what is its rating, what are the items available, and how much its price, description of that pizza, like what type of pizza is it. So you will get a lot of restaurants, right? Not one. So you'll get list of all those restaurants nearby you. So that is the place where in the backend nested data structures are used. Okay, so this is one of the examples. So here you can see how it starts with a list, and inside a list you have dictionary. So this is called list of dictionaries. Okay, so here is an example image. As soon as you type pizza, so it gets you all the restaurants, what are the restaurants available. So as soon as you click one of the restaurants, it gives you all those details. So in the back end, how does it happen? So it brings all these metadata in the form of nested data structure, and it displays you easily. So you don't have to go through all these complexities as a user of this app, but this is what happens in the backend when the server responds. So this will be a live data. So similarly, we'll look another example, a ride booking app. For example, we have Ola, Uber. So as soon as you enter pick and drop locations, in the front view, what you see? You see cab types, mini, sedan, SUV, and the estimated fare, the driver details. So all these happens live. So how does it do? It does send a request. So as soon as you enter pick up and drop location and hit uh, uh, estimate or hit book, then it will send a request, then it will get back a response. So this response will be live, and you will get all these responses in this format. So you don't understand. So will you be able to understand in this format? No, we will not be able to understand this format. So what does this mean? So this is an API, so an application interacting with application. So when the app gets the response in this format, it parses and displays you in a format that is understandable to you as an end user. So in the backend, it uh, brings the nested data structure. So here you can see this is a dictionary. So it starts with curly braces. So inside a dictionary, we have lists. So you can see our value is in list. So it ends here. So this is a key of a dictionary, and this is the complete value. So this is a list. So this is dictionary of lists, and again we have dictionary inside list. So it's like, if you see overall, it starts with dictionary, and then again we have a list. Inside a list, again we have a dictionary. So this is a nested data structure. So this is how uh, it happens behind the scenes. So this is example of Ola Uber app. So we'll see another example of train booking app. So let's say a scenario where you are searching trains from Hyderabad to Delhi on IRCTC app. Okay, so in the front end, you see train name, its number, its timing, and what are the available classes with price. Okay, so what you do, as soon as you enter the locations of source and destination and you hit enter, so behind the scenes, the application will get the responses from the server live, that these are the train available, this is the train name, train number, departure, arrival, classes, all these. So is this the data that you see on its app? No, this is not we see in a plain simple front end view, but in behind the scenes, this is what happens. So the API request and response happens through this data structure. So that's why this nested data structure are very important to build backend processes. So here you can see we have a list and dictionary. So this is list of dictionary, and we have dictionary of dictionary. So inside dictionary I have one more dictionaries. So this is combination of list of dictionary with nested dictionaries, and so this is how it brings back the data. So this is one of the examples. So let's say one more example. So you might be using ChatGPT or Gemini tools. So these are the AI tools that we might use a lot. So you, let's say you entered one of the sample, like summarize this paragraph into key points, 3 key points. So what does it happen in the backend? So in the front end, you see just simple chat window with a search box. So as soon as you enter your complete paragraph, you paste it in the chat window and say summarize this in this paragraph into 3 key points. What happens is it takes your input and converts it into whatever the data structure it understands. So then what does it do behind the scenes? It creates a request body. So it says what model I should use. This is the message of the user. So users, this is the role. So chat gpt applications like chat gpt, Gemini, so they are role based. So when you write something, so it first takes what role you are taking. You can change this role and ask it to behave an expert role, something like that. Then it takes your content, so whatever you have entered, into a dictionary. So complete request body like that you have requested through chat gpt, it takes your content. So this is the actual content that you entered. So it, your paragraph and your what you are asking. So it takes your request body and sends this request body to the chat gpt llm. Then behind the scenes, it know breaks down all those details, like what is the id, what is the object, what are the choices, the role of assistant. Here is the summary, point 1, point 2, point 3, and finish, reason, stop, index 0, what is the usage, and how many tokens. So tokens is number of uh, text text that it has brought, number of words it has, a user has entered, and number of words chat gpt has prompted as output. So the combination of all those is called total tokens. So total tokens is number of words. So this, when you enter something in chat gpt search, this is how it sends your request to the chat gpt server, and it will bring back the response in this format. But at the end, so is this what you see in the output in chat gpt a window? No, we don't see this. So this process happens in the backend. What you see is plain simple text of 3 points from that paragraph. So we ask chat gpt to bring 3 points from this paragraph as a summary. So it will display you just this, the content, in in a way that is understandable by you, reducing all these complexities. Okay, so what is this? This is a dictionary with a nested list of dictionaries. So here you can see this is a dictionary with nested list. So this is one list, and inside my list I have another dictionary. So this is a dictionary with nested list of dictionaries. Okay, so So far we have seen the examples where these nested data structures are used. Let's go back to our main topic, which is the types of commonly used nested data structures. Okay, so what are the commonly used nested data structures? We have a list of dictionaries. So I have a list. Inside my list I have dictionaries. So this is how it looks like. How do I access my list of dictionaries? I can say students. So I'll pick my list of dictionaries and I'll execute. So as you have learned, in list we have indexes, but in dictionaries we cannot access dictionaries by indexes. We have to access it by its key. So since this is my list, I'm accessing my list by its index. So let's look at how does it look like when I just access my list with its index. So it brings this dictionary. So what I'm saying, I want just to output name Alice. So I'll access my dictionary. So this is my dictionary. So I'll access my dictionary with its key. So this is our key, this is the value. So when I access my key name, the value Alice will be printed. So let me run this. So this is how it will print. So next commonly used is dictionary of dictionaries. So here is my dictionary. Inside my dictionary I have another dictionary. So how do I access my dictionary of dictionaries? So I can mention the key as to both keys in a nested way. So let's say I want to output bob@example.com. So how do I access it? So I'll say users of. So when I first access user, let where is my bob@example.com? Is it's in key 2 or user 2. So first I will access user 2, then I will access the email from the user 2. So what is the key here? Key is email. So when I access this, I'll get the output as bob@example.com. Then another example we have is lists of lists. So a list inside a list. So this is an example of matrices. So let's say you have a matrix 1 2 3 4 5 6. So I want to access matrix at index 1 comma 0. So what it will be? 3. Okay, so this is my 1. So this is my 0, this is my 1. Okay, so this is my 0 index, and this is my 1 index, this is my 2 index. So what I'm saying, from this 0th index I have again 2 elements, that is 1 comma 2. Okay, so what I'm saying, 0 comma 1, again I have 2 indexes. So here I have 2 indexes inside my 1 index of 0 comma 1. So again I have 2 indexes inside my uh, second index, that is 0 comma 1. So what I'm saying, from 1, so from 1 index get me 0th value, 0th index value, so that is 3. So that is what we are getting it here. Next we have list of tuples. Okay, so here is my list, and inside my list I have tuples. So how do I access? So let's say these are coordinates. So I'm saying I want to access the coordinates 20. So how do I access it? So what I can say, so here is my coordinates. So this is my 0th index, so this is my first index. So from this 0th index I want to access the first value. So then this will be 0 comma 1. In this 0th index I have two values, so that is 0 comma 1. So now I will access 0 comma 1. So from 0 I am accessing one value. From this is complete 0th index. From this 0th index again I have two elements, so that's why I am saying this value is 0, this is 1. So I want to access 1, so I'll get the coordinates 20. Okay, so in short, we can see we have all these types of uh, nested data structures: list of dictionaries, dictionary of lists, dictionary of dictionaries, list of lists, list of tuples. Okay, so make sure you always understand what each level of nesting contains, like how to use indexing. So in lists we can use indexing, in tuples we can use indexing, but in dictionaries we cannot use indexing. We can use key values, that is the what is the key of that value pair. Okay, so okay, so let's see a sample example. Like here is the dictionary with tuples as keys and lists as its value. So example, so here is a student score. So what I'm saying, Alice and Max. So student name and its and his subject is my key, and the list. So this is tuple. What I'm saying, in my dictionary, so this is my dictionary. Inside my dictionary, this is my key and this is my value. This is my key and this is my value. So you notice keys are in tuples data structure format, whereas values are in lists data structure format. So how do I access it? So to access it, I can say I can just print this. Okay, so if I print this, okay, so here already I have the example here. So I have the student scores along with their marks. So what I'm saying, access Alice math marks, math. So what I'm getting, 85, 90, 92. Access Bob's science, that is 1. So science at science 1 marks. Okay, so marks at first position. So I'm getting, when I'm accessing 1, I'm getting 88. Okay, so here consider this example. Maybe like Alice have got marks, he have written exam 3 times. So first time when he has written, he got 85. Second time he has written the exam, he got 90. Third time when he has written, he got 92. So here what I'm getting all the marks of Alice in his all attempts. So I'm able to get all his marks. But when it comes to Bob, what I'm saying, I'm saying get Bob science marks. So this is my key. Okay, and I'm accessing key, and what I'm saying, his first attempt. So this is first value I want to get from his marks. So since in list indexing it will work, indexing in list indexing, so this is how it will work. So this is my 0th position, this is 1, this is 2. So okay, so in terms, I'm saying access his second attempt marks. So that is index 1. Okay, so when I run this, I'm getting 88. Okay, okay, so okay, so a quick recap. So you can focus on learning these concepts. So what is list of dictionaries? Why it's used? Like it's using API responses with multiple users or products. A dictionary of lists, it's used in filters, tags, group, data category. Dictionary of dictionaries, where it's used, user profile, system configurations, list of lists. It's using CSV or Excel like data. Nested access patterns, like accessing list along with the dictionary in multiple nested, if it is nested multiple times. So if you practice these, and you'll be able to easily crack these nested data structures. So why it is important? As we have already seen in the above example, that it's used in real world. And also APIs speak with the data structure. So there are a lot of APIs nowadays, and as a human being, if I want to speak to someone, so I'll directly speak and I'll get the information. But the applications, they cannot speak directly. So they talk in the form of request sent and response got back. So as they send the request in the form of a data structure, and they get the response also in the form of a data structures. So everything is nested here. So most real world data is not flat. So we have nested data, as you have seen in the example of food delivery app and ride sharing app, or train booking app also. So this is essential for job roles, whether you are looking for data analyst, data engineer, Python developer, web developer. So this is very important even for DevOps engineer. So if they are configuring some system, so this might be very important for them to learn these nested data structures. So you need to work with API responses, files, configurations that use nested data structures. So if these are the work that you are trying to do or you want to do, you should learn nested data structures. So what happens if you skip this nested data structures? So you'll get stuck handling with real world data. So a lot of real world data is live now. So there is no more batch. So now the real world data is the combination of batch and stream processing. So as soon as we request, we want the response back. So we are handling a lot of real world data. If you do not use nested data structures, you will face common errors such as key error, index error, type error, these types of errors. And you'll also struggle in interviews. So there are a lot of questions asked in interviews about nested data structures. You will struggle to answer these questions if you do not prepare for this, or if you skip this. So you have to parse these data structures using Python or any other language. You can use other languages also to parse these data structures. Okay, so finally, if you can complete this nested data structure, understand how to use nested data structure, you can build real world apps and APIs and data workflows. So it's one of the most practical and higher worthy skills that you can learn. Okay, so now we'll see some of the exercises to master nested data structure. So let's see some of the exercises here. Okay, so this is my uh, nested data structure. So this is a student data structure. So it's a dictionary. Again, this dictionary has nested dictionary, and again inside my dictionary I have a list also. Okay, here you can see I have a list also. So it's a dictionary and list. So here are some of the exercises that we will solve to uh, learn our nested data structures in detail, and get our hands dirty, and we'll understand how to work with nested data structure. So here I have compiled 30 different types of problems that you can solve to master this nested data structure. Okay, so we already learned dictionaries, lists, tuples, all those. So now let's use all those knowledge that we learn here to solve this problem. So here is our data structure. So let me minimize this to show you how does it look like. So this is the data structure. So using this data structure, we have to solve all those 30 problems, find out different scenarios regarding bringing name, marks, summing up, averaging, all those things. We'll see it one by one. So, okay. So first, let me run my nested data structure. Okay. So this is our students data structure. So it's a dictionary of dictionaries. So this is how it looks like. So it has a key. Main keys are this A101, 2, 3. So three IDs we have. Three IDs and their student details. So we have three student IDs and student details here in this nested dictionary. So inside the dictionary, we have one more dictionary, and inside our dictionary, we have a list also. So now let's go to the first question. print the name of all the students. Okay, so we want to print the names of all the students. So what are the names here? There are three names: Alice, Bob, Charlie. So I want to print the name, just the names of all the students. So how do I do it? So let me write this for s in student dot values. So if I execute this, so I'll get all the values. So all these values I'm getting it. So all these values. So I'm ignoring the main keys. Okay. Now from this dictionary, so this is the in nested dictionary. So I got the values as dictionary. So again from this dictionary, I want to just extract names: Alice, Bob, Charlie. So how do I do that? So I'll use this s. So I'll use s, since s contains all these dictionaries. So I'll say s of name. So when I say s of name, I'll get only three: Alice, Bob, Charlie. Three names. That's it. So that is how we can solve this problem. Okay. So there is another way we can approach this. So we already saw list comprehensions. So this is a shortcut way of getting. So when I say s of name for s in student dot value, same thing I can write in list comprehension. So I'll get Alice, Bob, Charlie. So this is just one liner, makes our code easier, easy to read, and just in one line it executes. Okay, so let's solve our second problem. Okay, so what do we want? We want to get all the student names for student ID A101. Okay, so first let me get students. So what is our students? Okay, so this is our students data structure. So from this student data structure, so what I'm saying, I'm saying get list of all the students. So what are the list of students? So I'm getting all the keys, that is student IDs. Now from these keys, what I'm saying, pick first key, because I'm interested in A101. So what I'm doing, I'm just picking first key. Now I'm getting the nested key. So inside my A10 key, I have again three keys, that is name, subject, year. So you can see name, subjects, and year, three keys. So from these, again from this, what I'm picking from A101, I'm saying just pick subjects. So I am interested in whatever the subjects we have. So when I execute this, I get two subjects, math and science. So next program I have is print the highest math score for Bob. So what I can say, I'll get student B202. Same way I can say I'll access student B02 and subjects and his math marks, and I'll say max. So when I say max, so I'll get 75. 75 is the highest math score for Bob. So same way, the fourth program is calculate the average science score for Alice. Okay, so first I have to get the science score for Alice. So this is how I can get student of the key A101. Since Alice is in the student key A101, so I have to pick A101. Then I'll pick the subjects of Alice, then the science marks. So first I have to get his science marks, then I have to I have to use the sum function to aggregate his science marks. Then I have to find sum of number by length of numbers, so that will get me the average. So here I can see I will get the average science score for Alice. So next is I need to add a new subject, history, with scores. So before adding, I'll show you what is my students data structure. So here you can see students data structure. So this is my student data structures. So what I'm saying, add history. So right now I have math, science, maths, English, science, English, but I don't have history. So now what I'm saying, add new subject history to C303, student ID 3. So let me run this. So here, So first, what I'm doing, I'm accessing this. I'm adding the subject, and inside the subject, I'm adding uh, another key called history, and inside that key, I'm adding two values, 80 comma 83. So let me execute this. So this is how it will look like. So before this, we didn't have history here. So after English, we didn't have history. Now we have added history to C303 student. Okay. So now next, let's look at another one. So let me add. So let me run students data structure. So this is our students data structure. So history remain as it is. What we are saying, at one index number 1, I want to update English score to 90 for B202. So this is my B202 ID, and I have to go to the subject. Inside the subject, I have to go to the English. So for English value, so this is 0th index in my list. So this is first index in my list. So what I'm saying, at this place 82 number, update the English marks as 90. So let me execute this. Now if I run this, so you can see, so this value has been updated to 90. So here it was 82, now it's updated to 90. Now next, what we are saying, add a new student. So here we have three students, A101, B202, C303. Now what we are saying, add another student, D404. So his name David. Here is the subjects, here is the year. So let's execute and run our students data structure and see. Here you can see student, an extra student D402 has been added. Now we want to say that delete student subject English. So we want to delete English record for student 302. So this is how the statement is. Delete student. We are accessing first key, that is student 303, and second key, that is subject, the third key, that is English. So this way we can uh, delete student marks. So once we have deleted, let me run students data structure. Here you can see there is no English marks for student 3. Previously we had English marks 80 and 90 for student 3. Now there is no English marks here. Next, what we are saying, print all the students who are in the year 2023. So who are all in the year 2023? We have Alice, that is A101, and C. So two students are in 2023. So this is a list comprehension. We write it for s in student dot values. If s of year equal to 2023, bring their name. So this is how we are seeing. So if I run this, I'll get. If I run this, I'll get Alice and Charlie. So Alice and Charlie both are in 2023. Now again, what I'm saying, create a list of all student names and their years. So from this nested dictionary, complete dictionary, so I want to create a list just with student names and their years, respective years. So how do I do it? I'll declare a list, and inside the list I'll call the uh, I'll call I'll call the student by their key, that is name, by their key year. And how do I get those keys from here? For s in student dot values. So when we say for s in student dot values, we'll get these. I mean these just these structures. So from that I'm picking name and year. So let me print this. So here you can see Alice, Bob, Charlie, David. Okay, so now we are saying create a new dictionary with only names and their math scores. Okay, so what I'm saying, math score equal to dictionary of s of name. Uh, I'm, what I'm doing, first I'm getting values from here. So what will be my values? So these will be my values. So first this will be my value. So all these will be my values that will bring here. So this statement, first statement, will bring these values for all of these students. So from this values, we'll pick name here. I'll say s of name. So this is my s variable. So I'm saying s of name, and then s of subject. So this will get my subjects. So from that subject, I'm saying dot get math. So I'm saying from that subject list only get math and what are uh, scores. So when I print this, so I'll get all this. So let me just remove it for a second from here. Okay, so let me run it. So this is Alice and then math marks, Bob math marks, Charlie, David. So all these are printed here. Now next program we have is print all subject and scores for each student. For okay, so here you see for s in student dot values, print name and their subjects. So here you can see we are printing name and their subjects, and their scores will also be printed. So now we are saying find the total number of subjects for each student enrolled in. Okay, so I want total number of students. So I'm saying the student name and number of subjects they are enrolled in. So for that I'm getting keys here, values here for student dot items. So you see Alice 2 subjects, Bob 2, Charlie 2, David 2. So count how many students have taken science subject. So this is my sum of science in subjects. I'm saying for, so this is my logic and this is my comprehension. So for s in student dot values, so how many science subjects we have? So I want to count. So sum of will be 3 students have taken science subjects. So how we can confirm it by rerunning our students dictionary. So how many students have science subject? So Alice, Bob doesn't have science subject. Charlie has, and David has. So this is how we can get. Now our 15th program, list of students who have scored above 90 in any subject. So first I'll get for s in student dot value. So this will get me all the values. That is, this is my key, student key, and the value is this part. So I'll get all the values. From that values, what I'm saying, for marks in s of subjects dot values, again I'm writing a nested dictionary to get just the subject values, and I'm writing a conditional statement. If any score greater than 90 for score in marks, print their name. So I'm just breaking my loop here. So let me run this. Alice and Charlie, both of them has marks greater than 90 in any subject. So next I have print the lowest score across all students for math. So I have math equal to all for s in student dot values, math underscore all plus subjects dot get math. So here I'm using first statement along with an increment. So I'm saying print the lowest score across all students for math. So if I run this, 70 is the lowest score. So I can see where is 85, 70. Okay, so 70 is the lowest score for math. Okay, so now what I'm saying, create a new dictionary with student names as keys and total scores as values. So from that original dictionary, I want to create a new dictionary. So my original dictionary is, so this is my original dictionary. So from this original dictionary, I want to create a new dictionary with just student name and sum of marks as key value pairs. Okay, so Alice total marks, Bob total marks, Charlie total marks, Davy total marks. Okay. So this is how I can perform my operation. So now next question we have, for each student print subject wise average. Okay, for S in students dot values. So what this student dot values will get. Okay, so we already seen. So let me show you quickly. Print S. So when I print S, student dot values, we'll get all these. So from this, we are extracting just the name. So when I extract name, I'll get Alice. Then again from when I extract subject and marks, oh, I'm able to sum. So what I'm doing, sum of marks divided by length of marks. Okay, so let me comment this out. So if I finally run my program, so you can see Alice math 89. So here we are using floating point value as a formatting. So that's why we are able to see this 0.00. Okay. So next we have check if history exists for any student. So we want to check if the subject history exists for any of the students. So we have seen membership operators, right? Any. So this is one of those operators. So any of history. So this is my string. So in subject. So I'm checking any of the string, any of history subjects, history text history exists in subject. So I'm accessing subject by looping my student dot value. So if I see whether it will bring me true or false. Okay, so next I have another program, add computer science with an empty list to all students. So for uh, so what I'm saying, subjects dot set default computer science. So add computer science with an empty list. So I want to just add empty list. So here, this is how I can add it. So let's, before adding, check what is the students dictionary. How does it look like? So do we have computer science? So we don't have computer science here. So once you run this, and we can see computer science as an empty list to all students. So you can see student 1, student 2, student 3, student 4. So this is how we can add it. Now next program 21 we have is remove all scores below 80 from each subject. Okay, so here we can see we are extracting values. From that values, again we are extracting subject values, and from that subject values we are writing an expression. We are grabbing that in a variable and writing a list comprehension. So I'm checking if the scores or below scores below 80 from each subject. Remove all scores below 80. So what I'm saying, I want to remove all scores below 80 in each subject. So for that, I'm grabbing all the subjects that are greater than 80 only, then I'm printing it. Okay, so I'm printing all those subjects that are greater than 80 only. So there is no subject below 80 here. So now program number 22, you're saying write a function to get all scores of a student given ID. So I have written a function get scores of student ID. So we are returning students dot get student ID dot get subjects. So based on the given ID, it will return student ID and their subject. So let's query A101. So we'll get A101 has maths and it's marked science, computer science. And if you query another student, C303, you'll get the science marks of this given student ID. So now again, one more program is write a function to return names of students who have more than 2 subjects. Okay, so have written a function. So we are returning, so whatever the value we are returning is name of the students who has more than 2 subjects. So here is my logic. I'm grabbing those student names here. So I'll print my result here. So let me run it. So Alice, Bob, Charlie, David. So these students have more than 2 subjects. So now add a new score to specific subject for a student using a function. So I'm saying add score. So for B202. So let me check my students data structure. So B202, does it have history? So it doesn't have history here. So it has Mac, English, and computer science. So I'm doing a add score function. So already written. So this will append the history and its marks to the B202 ID. So when I run it, so you can see B202 has history. So next we are saying replace all score with grade letters. So instead of showing scores, we are showing grade letters ABC based on scoring rules. So I have defined a function grade score, return A if score greater than equal to 90, else B if score greater than or equal to 80, between 90 and 80. So we are saying B, below 80 we are saying grade C. So if I loop through, if I run it, yeah, I can print this. Okay, so we need to call this function grade, grad, grade. Okay, so I have to pass the number. So if I pass the number, I'll get grades based on the number I have passed. Okay, so I need to, so there is no grades here. So I need to, since there are empty lists, this is erroring out. So what I have to do, I have to redeclare my original students nested data structure. So let me redeclare it. So I'm rerunning this part again. So now let us come back here to the 25. Okay, so let me come back to 25. If I run this, I can see instead of marks, I can see my list has been, my dictionary has been converted to grades, student grades. Okay, so similarly, again I have one more program, print only students who have all subjects with average greater than 85. Since my dictionary is converted to grades, again this program will also error out. So again I will go back and rerun my dictionary, original dictionary. I'll reset this. Okay, so I'll rerun this part. I'll come back to 26th problem, number 26th. Okay, so what I'm saying, print only students who have all subjects with average greater than 85. Okay, so only Charlie has average score greater than 85. Now what I'm saying, create a flat list of all subject names from all students, no duplicates allowed. So in this, uh, what I'm doing, subjects is equal to set. I'm converting my subjects to set. So I'm declaring a variable subjects and writing an empty set. Then I will grab that into my set. So what I'm saying, for s in student dot values subjects dot update. So what I'm saying, update all my set with subjects. So by default, what's the nature of a set? It will not allow duplicates. So since I'm grabbing all these values into a set, it will remove duplicates. So let's first see what happens here. So when I print this, so I'll get science in English. So let me comment out this also. Print subjects. Okay, so I'm getting only two subjects. Create a file list of all subject names from all students. Okay, so let me recreate my dictionary again. So let's see. Okay, so this is my dictionary. Go back to number 27 problem. 27th. Okay, so before running my problem, let me query my students. Okay, so this is my dictionary. So now let me run this sample program. So let me comment this out also. Okay, so I'm able to get all subject names from all students, no duplicates. Okay, so what are the subjects? Max Science, Mac English, Science English. So I'm getting Science and English. So where is Maths? So where is Math here? Math. Okay, for 27th problem, print flat list of all subject names from all students. So you can see we are able to print Science, Math, English. So these are all the list of a list of subjects. Now find which student has highest total score. So we are grabbing the total score inside our dictionary again, and inside the dictionary. So we are seeing dictionary comprehension. We are using it. We are grabbing. We are declaring our key, and this is my value. So this inside the value, I'm writing an expression. Sum of marks for marks in subjects dot values for s in students. So this is my nested dictionary comprehension. So I'm able to grab the total scores for each students here. So before printing, uh, so here we can see print. If I print total scores, so this is how it looks like. Alice 431, Bob 390, Charlie 364. So now what I'm saying, print max. So only the max score. So who got the maximum? Alice got the maximum. Then problem number 29, sort all students by total score in descending order. So sorted students, so we are using sorted function. So inside the sorted functions, we are bringing all student values, that is my all the keys, along with the student name, subjects, all. Then I'm writing lambda function here. So I'm grabbing that key here into the key variable lambda s. This is my key and this is my expression. So I'm doing a summation and grabbing all those values by writing this expression from the subjects. So I'll grab total score and reverse equal to true. When I write reverse equal to true, that means we are sorting in descending order. So when I run this, Alice, Bob, Charlie. So that is how sort all the students by total score descending order. So this is how we can write a function. So next I have this is the last program. Export all student data as list of dictionary. So we are doing a flattened structure. So I'm declaring an empty list. So from this empty list, what I'm doing, I'm declaring two key and value variables and student dot items to grab those key and values in dictionary, and what I'm saying, entry equal to, so this is my variable, so id equal to sid, name equal to s of name, year. So this is my formatting. So this is the formatting that entry dot update. So what I'm doing, I'm updating my list. So this is my list with subjects. So then again I'm calling flattened, that is the declared list, and appending my list with entry. So this is how it looks like. So I have successfully converted my dictionary, nested dictionary, into list of dictionaries. So this is how I converted it. So okay, so far we have seen uh, all these exercises to fully grasp the nested data structures. So those are list of dictionaries, list of lists, dictionary of dictionaries, list of dictionaries, dictionary of lists, and a list of tuples. So combine all those. These nested data structures are very important. Okay, so thank you for staying and listening to this session so far. So I encourage you to practice all these to get your hands on these nested data structure, so that you are able to grasp the concept fully and able to solve the interview problems easily and solve real world problems also. Okay, so that's it for today. We'll meet tomorrow. Thank you. Bye bye. Hello everyone.